Aloha, amigos. What's happening? Welcome, everyone, to another day of the Apply Conference. We are back in action. Thank you for joining us once again. This is something very special. We have had some incredible speakers so far. It has been one hell of a day yesterday, and today we hope to just not hit that same bar, but make it better. We're going to try and do all we can to make it the most amazing conference that you've been to this year. It doesn't matter if you're talking about ML or DevOps or whatever tech you like. So, a few things. Let's just go over some housekeeping while we're here and we're starting in case you missed it, right? Day 1 was a hit. I talked
¿Qué onda? Saludos. Estamos de vuelta con la conferencia el día de hoy.
into the Slack channel, which we're going to be posting in the chat right now. If you're listening on Zoom or watching on Zoom, or if you are on YouTube, we're going to be posting the Slack link if you're not in there already. So get in there, be active, and yeah, use Slack. What's really cool is we've got like 3 dedicated channels for the Apply conference in that Slack. One is the funny channel. So if you're not in funny, go get in it and have some laughs at the selfies.
¿Qué onda? Saludos por ahí a los que van llegando.
So somebody gets a big +1 if you can do something creative with the applied networking channel. So it's not just a bunch of LinkedIn links. That being said,
No estoy diciendo nada interesante ahorita, salvo si quieren conectarse al Slack. Paso el link. Ahorita voy a poner el link de la conferencia en el chat.
and we can like make this a community thing. Ask the questions and
¿Qué onda, Luis Fernando? Espero andes bien por allá. Aún no logro arreglar eso. No entiendo por qué. Lo esto muchísimo.
accidentally did not give enough swag away yesterday. So today we're getting even more swag. All right. So the conference is it's been pretty cool. You know, it's got like just the right amount of people trying to sell you shit and actual thought leadership, I think. And speaking
Me fascina cómo acepta que la mitad de las conferencias es gente tratando de venderte cosas. Sí, de eso se tratan. Muchas conferencias. Hay buen contenido, pero también hay muchísima gente tratando de promocionar sus productos y de venderte cosas, a final de cuentas. Que me gusta que lo haya aceptado.
do before we actually get jumping into the full conference with Todd, who's coming up, and I'm actually super excited for that. But hold on, Todd. I see you coming. I just want to share my screen real fast because there is one person who won some swag yesterday and he did not claim it. So Cedric, if you are out there listening, I know it was really late for you yesterday when I announced that you won. You get some swag. So contact me on Slack. The other thing is that we asked everyone to fill out this poll and the results are in. I know everyone at this conference loves to see data and visualizing data is even more fun.
¿Está bien el volumen del audio o le subo el volumen?
A lot of people said, I don't care, which is surprising to me. Then 31% said no, 20 or 18%, sorry, 27% said no, and 18 said I agree. And then there's the strongly agree, and 11 strongly disagree. So that is a really interesting one to think about. Now, is MLOps an organizational problem? I have a feeling, Todd, you might be talking about this later, but we have agree and strongly agree are the main ones on this. So, yeah, we know how we stand
Por ahí también ya sé que MLOps es un concepto relativamente nuevo para esa comunidad. Pero bueno, ahorita lo que preguntan es que si MLOps es un problema organizacional o un problema más técnico. Bueno, me parece a mí que de lo poco que sé es un problema mucho más organizacional, a mi parecer.
Ooh, 2 months, it just goes, it's some nice stuff. But really, what I want to just show you about right here are these. Have you ever had a model go rogue? Tell us the story. This is hilarious. And I am going to figure out a way that we can share this in Slack.
La conferencia se llama Apply. Supongo que se hace en referencia al famoso método Apply de Pandas. A el famoso método Apply de Pandas.
People who are vegetarian and they don't hunt. But there's this one, train a model on historic data, looked at every possible way it.
Hey, saludos Alejandra. Gracias por apoyar por acá. Andamos viendo una conferencia. Todavía no empiezan las conferencias. Nada más estaban pre-show.
Most important feature took 3 weeks to stabilize, which of course had been an issue and wasn't visible when it was on historic data. Most embarrassing. It wasn't until we used the model for several successive months predictions till we figured out what was happening. So, whoever that model gone rogue story is, tell me, and you're going to win some swag. So, there we go. That's it. Next up, I'm going to introduce my man Todd. I will ask you to come back on now.
Son las 5:11 de la tarde.
To everyone.
Yeah. So let me just tell everyone why they should be listening to you in case they missed it.
Aunque bueno, creo que el horario de la conferencia es el horario de Los Ángeles. Son 2 horas antes de la ciudad, del centro de la Ciudad de México.
I love that title, man. You could be a copywriter. So if anyone doesn't know who Todd is, he leads the machine learning site reliability engineering for Google and is the site lead for Google's Pittsburgh engineering office. Prior to Google, Todd held various roles at, you're going to have to help me with this one, Renesas.
Renesas, sure.
Yeah, and so here we go. We're going to talk about why ML-centric, the only truly hard problem in MLOps is the data. I'm going to kick it off to you, Todd. And just a shameless plug before I do, if anyone wants to see more of Todd, we recorded some coffee sessions or podcasts with him on the MLOps community. So if you're not in the MLOps community, get in there and we'll leave a link to that in the chat or in the Slack too. But for now, it's all you, Todd.
Fantastic, Demetrius. Thanks a lot for the introduction. Let me just hit the present button. I'm hoping people can see that. If you can't see it, this will still be.
Nos va a hablar de, según el único problema difícil en machine learning.
Said, I'm Todd. I do ML at Google. This is some work, as it was pointed out, quite correctly, some clickbaity work that was done with my colleague Niall Murphy. I've been doing machine learning stuff at Google for about 12 years here in the Pittsburgh office. Niall has spent the last 15 years working for Amazon and Google and Microsoft and has done a bunch of machine learning stuff as well. And Niall, you may know from his role in creating and as the lead author of the SRE book. So if you don't know that, that's fine. By the end of this talk, you'll be convinced to know that. I don't know if you will. So the title was, yes, the only truly difficult problem in machine learning, but that's of course nonsense. Really, that's an exaggeration for effect. I want to talk about the only truly difficult problem in machine learning: reliability, operations, and production. And again, even that's an exaggeration, of course, but people only come to things that are a little bit exaggerated. But I do want to point out that there are a lot of problems that we have that are not machine learning problems. And there are already good solutions for those. And that's the punchline, is that I want to point out a bunch of problems that aren't really our problems as MLOps folks, and have already been solved pretty well by some other people, so that we can focus on the problems that are our problems. So we have many problems. We have so many problems to choose from. So MLOps generally concerns itself with producing reliable, high quality ML systems. But these are, of course, complex, interdependent, multi-stage pipelines. When you hear stories like the one that was just told about a model that has to work on a lot of data in order to stabilize, but that doesn't show up until you actually put it into production, that stuff is pretty common for us, right? So that complexity in the interdependence is really what we're looking at in these multi-stage pipelines. And so the thing I want to convince you of is that we already have techniques in computing, and in particular in site reliability engineering, for addressing these. And if you don't know what site reliability engineering is, don't worry, I'm going to explain it, or explain it sufficiently well that we can pretend we all know what it means. So let's talk about machine
Ahorita va a decir de qué es a lo que se dedica.
would like to achieve. So for those who haven't seen this term, SLO, a service level objective, it's just something we want to be true in the world. And when you express it that way, then you can build a system that tries to accomplish it, and you can build monitoring and emergency response that tries to achieve that. So let's talk about like training pipelines. What do we want from a training pipeline? If you're sitting around, you're like, well, I want my models to finish training on time. So finish is the good part. And then on time is whatever on time means for you. It could mean a particular speed. It could mean by a particular deadline. It could just mean before you wake up the next day. But on time for you, we want our model configurations that are updatable, are durable, so we don't lose them. They're probably versioned. We can troubleshoot them, and they work. When I say like, and functional, they work. They create models that work. And we want these trained models that result from our training to be usable in some format, broadly usable. So are they correctly formatted? Will they load into the next stage of the pipeline? Do they have reasonable quality? We're coming back to quality in a minute, so keep your attention on that. What about the data ingestion system? Well, we want the data to be readable, correctly formatted, interpreted. We want data that are ingested quickly, right? We don't want to sit around waiting for the data to appear. We only want data that are accessible and only accessed by the right users in the right program. So a lot of us deal with some data that's pretty private, which is great. Like that's fine, but you need to treat it appropriately. So you need to restrict access to it, and you need to log that access. Okay, good. Sounds good, right? What else? Oh, we're going to have some sort of feature storage system, right? Here we are at this gathering. We've heard a little bit about some feature storage systems. So, but we don't just want to store features, I think we want to store features. We want to store model snapshots. We want to store configs. We want metadata about all of that stuff. That doesn't have to be one system, but it certainly, all of those needs have to be met somehow. And if not, we're just, slapping things in directories and hoping for the best, which is also fine. But like, you just have to acknowledge that is your storage system if that's what you're doing. We want features that can be read quickly and reliably. We want configs that can be updated and validated for all of our storage systems. And we want the data to be durable and correct. Durable for people who don't do data integrity stuff just means we don't lose it. It's a fancy way of saying data we don't lose. Okay, cool. Serving system, we want queries to be fast. If we're looking up stuff, we want them to be fast. Whatever fast means, and error-free, whatever error-free is acceptable. Not error-free, but low error, really, I should have said. Whatever low is acceptable for you. Models that are updated. If you have a new model, you want to replace it in serving, it should work. We want query logs because we're probably going to use whatever questions and answers we asked about the model for training the model in the future as some kind of exogenous signal of what the model's doing. Okay. So many MLOps folks claim
Ese se supone que es mi trabajo actualmente.
and a lot of methodology that says, like, we're going to solve these problems in this way. We're going to have end-to-end automation of the ML lifecycle. We're going to focus on efficient sharing of compute resources, optimize your data storage, improve and standardize data ingestion, all of this stuff. Like, these are the kinds of things that many MLOps products and services claim to address. And this is the kind of work that many people who say that they are doing MLOps are doing. So that sounds fine. Like, that's just, here we are. This is our community, and these are the problems we're solving. So what I want to do though is take a step back and say, actually, these are not.
Igual si no lo entienden ahí algo, me dicen y trato de explicarlo o traducirlo sin problema.
Of what I just described are not MLOps problems. They're just software operations problems. They're just the kind of problems you have when you're operating large scale distributed data store, when you're operating a web crawler or a web page that you serve, or a payment system, or any of these things. Like the ML part is not what made most of those things hard. And so as a result, I want to take a step back and say, let's be lazy here. If somebody else already solved some of these things, or at least has good approaches for ameliorating these things, we should take advantage of that, right? Like, why reinvent things? Sounds good. So who has solved some of these things? Well, I know some kids who have done so. They're called SREs. So let me pause for a second and say, well, what is SRE? SRE, site reliability engineering, is an approach to doing large-scale systems engineering at Google. Started at Google, and now is like, a lot of different people throughout the industry have adopted this approach. And it basically treats operations problems as software problems. So apologies for that. That was terrible. Hold on.
Ya está explicando a qué se dedica un SRE por ahí, Luis Fernando, que preguntabas. Bueno, de mi trabajo fue todo. Me pagaban más, es diferente ambiente. El ambiente de mi previa compañía era bueno igual. Y mi interés se está moviendo muchísimo más hacia MLOps.
SREs treat operations problems as software problems. And there's sort of the approach that Ben Traynor, who is an early exec at Google, approached reliability engineering. So that's fine. So let's look through what is the bag of tricks that SRE has to solve some of these operations problems as if they're software engineering problems. So what are the kinds of things that SREs do? Well, we design redundant infrastructure. And I say we because like I am in fact do SRE work for ML. So we design redundant infrastructure. We treat configuration as if it's code, because it is code. It determines the functioning of software. We use distributed consensus. Not enough people really take that seriously, and it's really the only way to have sane distributed computation. Lots of focus on security controls and how those work. Enormous amount of focus on monitoring and observability. Lots of techniques for thinking about whole collections of computers as if they're one fleet rather than individual computers. These are all pretty straightforward approaches. Sounds good, right? So let's take a look quickly at how these map onto the problems that I just said were MLOps problems. Well, we see training pipelines. Those are the service level objectives we were trying to achieve. So how do we get models to train on time? Well, we monitor model completion and progress at various stages throughout the pipeline, and we alert when it's not. It's not magic. And that actually has nothing to do with machine learning. If you're processing a bunch of payments or you're indexing a bunch of data, you have exactly the same problem. Similarly, how do we check our configs are any good? Well, we validate the configs. We write validations against them, and we make sure that those validations pass. Similar, like if I have a trained model and I want to make sure it's correctly formatted and will load, well, I have a staging system where I try to load the model. And if it doesn't load, it is not valid. And so you might see the word model and think, what is that? Like, why isn't that the machine learning part of this whole system? But in this case, a model is just a bundle of software that needs to load into another piece of software, and it's either correctly formatted or it's not. So again, none of these problems is a machine learning problem. Similarly, data ingestion stuff. I won't go through all of these, and we will share the presentation. But the point I want to try to make here is that as you walk through this, you'll see each of these, like, are the data readable? Are they correctly formatted? Not a machine learning problem. We should monitor that data ingestion is succeeding, that we're not throwing errors as we try to read it. We can, test load some of the data. We can run assertions on the data ingestion and validate that the formats are correct. We can check the access controls on the data to validate that we have restricted it. And we can do so periodically, like once a minute, once an hour, et cetera. We can log access, and we can monitor those access logs. So again, no ML here. What about the storage system stuff? Same, right? Like none of this is about like, is a storage system working? Now, the distinction I want people to think through is the requirements we have for these systems are in fact machine learning requirements. Like, why do we want these things? We want these things because we're trying to build production ready machine learning systems. That's great. But how we solve those problems now has nothing to do with machine learning. And that's an important distinction and an interesting one. Similarly, serving system, I mean, to be honest, the serving system is probably the least machine learning part of it. Like, it's a distributed serving system, similar to a distributed web serving system or many distributed application serving systems. The constraints that it has come from an environment of machine learning, but the way to solve those constraints, again, is by running a high quality, well-monitored distributed serving system. So nothing to see here. So here's an observation I'll make, and then we'll talk about what's left. So the observation that I'll make is that all of these solutions are context-free solutions. So they do not depend upon the fact that the work that we're doing is machine learning, and the machine learning that we're doing is for some particular purpose. We don't need to know that to monitor the completion of our training pipeline. We do not need to know that to make sure that our models are correctly formatted and will load into our serving system, right? We just need to know we have a process that is finishing, it is producing a binary artifact, and it needs to get to the next stage, and the next stage needs to start. And the fact that it is about targeting an advertisement, or about predicting a purchase, or about the objects that are in a photo, that's irrelevant to the kind of work that is done to make that production. So that's, I mean, I've mentioned this to other people, and sometimes people get annoyed or frustrated. They're like, you're trying to take away something from me. I'm like, no, I'm excited that we don't have to work on this stuff. I'm not saying no one has to work on this stuff, but when we work on this stuff, we are not doing MLOps, we're doing ops. We are not doing, machine learning reliability engineering. We're doing regular systems and site reliability engineering, which is great because there's a ton of people who know how to do that and they're good at it, and we should borrow from their skills. And we should actually have them on our teams. And one thing I'll say honestly, and we can talk about that, I know it's a question that Demetrius brought up with me when we spoke. Most of the people who work on SRE for machine learning at Google do not have a background in machine learning, and it's not a problem. In fact, it's not even vaguely necessary. It's not to say they don't need to learn some of that along the way for useful context, but most of the problems are not machine learning problems. Okay, so wait, so are we done? Like, is that it? Did we solve all the problems? Unfortunately, no. The whole point of this is not what is not MLOps, but what is. So what's left? So where's the machine learning and machine learning operations? I want to make an argument. It's mostly hidden in the data, and this is the problem. So subtle changes in the distribution of data, both in positive and negative sense, can have enormous impacts on the quality of our models. And the quality of our models is in fact what we're trying to do. So one of the themes that I've heard as people discuss these things is like, oh, like MLOps should really focus on the business value, the organizational value. Yes, right. Again, we're not here to train models. We're here to accomplish some higher goal, which could be, sell more widgets, or it could be predict more weather, and it can be identify more oranges in pictures. But whatever thing we're trying to do, that's the thing that is the point of the whole thing, right? That is why we're here. So what happens if we have subtle changes in the data is that they're very difficult to detect from a systems level, but have profound implications on a modeling and quality level. So in order to do that successfully, in order to mitigate those problems successfully, necessary to have the whole picture.
Ahorita va una de esas temas controversiales. No creo que necesites un grado universitario para ser un científico de datos. Si quieres hacer un grado universitario para aprender ciencia de datos, adelante, pero no lo necesitas, en mi opinión.
System that we run on a website that sells yarn, right? Sells yarn for people who knit and crochet. Okay, so people search for things on this website, and we track the things that we show them and which ones they click on. And we use that as a signal to a model that tries to produce ranked results for a search engine as people are shopping for yarn. And maybe we use clicks, but we also use profit margin, right? Because we might choose to show something that isn't quite as popular for people to click on, but makes us a lot more money. I know that is base to say, but as a yarn seller, we might really want to make some money and want to cover our costs. And so we might do that. So now imagine that our app, like we are a global yarn seller, right? Like we are across the world. And for whatever reason, we have a system failure and we drop all of the logs from all of our Spanish language users. So we are no longer updating our model with the clicks that people whose browsers are set to Spanish are clicking on. So for our particular set, consider the possibility that this is only about 7% of our data. So if you're monitoring across your data, you might not notice it. Like that's well within the fluctuation of a normal daily cycle, right? You have these diurnal cycles and it would be difficult to detect that even. Okay. So what happens when we train the version of our model for the next day or the next hour or the next whatever, like we're going to update this model, our system will learn, incorrectly learn, that all results in Spanish are bad. That's not good at all, right? Like that's terrible. So as a result, our system will stop recommending Spanish language results, even for Spanish language users. This is really not good. So this is a common kind of a problem. It's not even a very interesting problem in some ways, but it is interesting to me because it motivates the question, if you didn't know this was a machine learning set of models, how would you detect that kind of an outage? And you say like, oh, well, I would monitor all the data arriving and make sure I had data. You're like, well, you would only know to look for data in Spanish if you knew Spanish was a valuable feature of the machine learning system, if you knew that was relevant. Similarly, if you knew that geography was relevant, you would look across geography. If you think time of day is relevant, you can look across time of day. But in each case, you have to know the machine learning purpose of the model in order to try to solve it. So note that this is a problem that is a modeling problem that's caused by an infrastructure failure. Okay, well, so now we know model quality can be impacted by making bad models. Lots of us have made bad models, and that'll continue, presumably. We're all trying to make better models, but usually start with the bad model. So we can have bad models made by modelers who have made bad models, but we can also have models that are made bad by infrastructure failures. And that's the class of problems I'm particularly interested in. So some infrastructure failures really will only easily or sometimes at all show up as model quality failures. I've listed a few examples of these, and most of you are familiar with some of them, so I won't go through them. But most of them have to do with cases where we have the data, but the mapping of the data to the meaning of the data, so the semantics have changed. Simple examples like I can change quantization of, if I have an integer for age and I quantize it on decade and somebody else quantizes it on 5-year boundaries, well then those just mean really different things. Like an index of 4 in that quantization is completely different and addresses a very, very different age for whatever that record is. And so whatever that example is. So you can imagine all kinds of things like this that are not, they're essentially invisible at an infrastructure level, but clearly visible at a model quality level. And so what I want to point out is that this leaves us with model quality monitoring is the only real end-to-end integration test of a machine learning system. And that is actually a little bit of a disappointing and terrifying result, because what it means is, as machine learning infrastructure engineers, we're not actually capable of building a system that is reliable in the true sense, because to be reliable in the true sense would be this system trains good models and puts them into production reliably. That is a wonderful thing to aspire to. That is not a thing we can achieve. And that's disappointing. And so the next step is, well, what can we achieve? Well, here are some best practices for model stability and monitoring. Most of these come from a paper that some colleagues of mine at Google, including the inimitable and well-known D. Scully produced, along with Eric Breck and a couple of other collaborators in the Cambridge office on the ML test score. And these are just straightforward ML test recommendations that they had. What I will say about these, I won't go through them all in detail because I'll leave time for a couple of questions. But what I will say about these is each of these is easier said than done. I included that note on the first.
Hablando de este paper, the ML test score.
That's great, but what's a change in a dependency? Like, how do I know if some data I'm consuming changed the meaning of one part of one column of data that I consume for my model? How would I even know that? But there are things that you can do that are relatively simple. So, you can look that you're not using massively more compute than you were using to do the same thing previously. You can keep track of how old your models are and that they're not older than you expect. So this set of solutions has a wide range, ranging from very easy and very straightforward, like keeping track of your model age is trivial. Useful invariants that hold across training and serving, that's quite a bit harder, because what is a useful invariant? And it's very context sensitive. So I think so what I'd like to leave you with, and then I'm happy to take a couple of questions, and I will also be on the Slack channel after this to answer other questions. But what I'd like to leave people with is a sense of sort of hope and dread. So the hope is that many of the problems that we think are really big problems, other people are already working on and have some good approaches to. Not to say like, I am not saying like, oh, these are easy. They're not easy, but they're hard in a way that has attracted thousands and thousands of other people who actually don't know that much about machine learning and don't care about it to work on. And we should take advantage of their skills. So that's the hope, is like, oh, we can probably do a lot better with a lot of the things we're doing by following best practices for distributed systems and by hiring some of the people who already know how to do that and getting them to help us. That sounds great. The dread part is, and then what's left is model quality and the intersection between model quality and infrastructure. And that is just, there is not an easy way for that. So thanks very much.
That was awesome, man. That was exactly.
Eso es de lo que les estaba hablando el Scott. No.
Super context dependent. So if you have a model that's trying to make money, you graph how much money it's making. I mean, it sounds really straightforward, but like, what's the model trying to do? If you have a model that's trying to sell things, how much of what kinds of things is it selling? So you really basically determine the slices, so the subdivisions of significance for that model, and you graph it out on that. So if you have a global service that's trying to translate things, graph how many translations people are saying are bad around the world, et cetera. So this is the sad part, is every question like that is going to have the form, well, it depends. What are you trying to do? Sorry for that, but that's where we are.
The nature of the beast.
Yeah, what
That's
else?
what you get. There's one about how you, Mr. Underwood, are implementing some of these best practices you speak of.
Yeah, so I think, so what we have done is, like, we grew machine learning SRE at Google out of SRE. It is not an outgrowth of Google Research. It is not an outgrowth of core systems. It's an outgrowth of SRE. And so in my organizations, I preferentially hire people who are good at distributed systems and interested in machine learning versus people who are interested in machine learning and willing to do some distributed systems. So that is one of the things I do. And I would encourage other people to do that, because I think it's a little bit offensive to us, but like, we just have to acknowledge you don't actually need to know as much about machine learning to do the production engineering of machine learning as people keep saying. Not to say it's not fun, it's not sexy, it's something we can do if we want to, but like the machine learning part, and part of this is being at Google, like the people who do that are so much smarter than me that I have no illusions that I'm going to be like that. Like those kids know what they're doing. I'm just over here. I'm just the machine learning infrastructure plumber, and I'm connecting up the pipes and I'm making sure that the bits are flowing through those pipes. And it just happens to be ML bits.
I love that outlook on it. Any thoughts on approximating model performance when you do not have ground truth labels or they are received on a delay? Best practices around that?
Yeah, so I think the important part of that question is the cheating easy best way is if you can get a golden set or you can get some ground truth. And so like, you know, when you don't have it, I do want to say like there's a couple things you can do, but man, if you can get a golden set, you can run your golden set through your model and say like, how's it doing? How's it doing?
¿Qué tan fácil es hacer data science para robótica? Digo, depende del problema completamente. No sé qué parte del que estés tratando de hacer. Y no sé qué sea arroz. Vamos a investigar. Porque bueno, la pregunta no estuvo tan buena. Pero eso es lo que él estaba diciendo hace rato. Que bueno, básicamente, cuando se habla de un sistema de machine learning, muchas personas piensan en solamente esta parte de aquí. Que bueno, si le hago zoom, pueden ver que es el código de machine learning, es el modelo. Sin embargo, a su alrededor, pues hay un montón de cajitas que no necesariamente están, están relacionadas con el machine learning, pero no necesariamente uno necesita conocer machine learning para realizarlas, para poderlas, para ponerlas en su lugar y para poderlas poner en producción.
I think, you know, it's difficult to answer that with precision, but what I love about that question is the implicit understanding that you don't get to be a data scientist without caring about the infrastructure. So I won't actually answer that question. What I'll say is I'm really excited that somebody asked that question, because what I'm hoping for is that more people acknowledge that they get to do the fun algorithm work and building the models, and they get to do the fun data analytics work, but they also have to care about how well it runs. And if they do, they're going to have a lot more fun, right? So what I would say is the more you care about production engineering as a data scientist, the more progress you will make in your data science work.
Todd, always.
No encuentro nada de arroz, Luis Fernando.
That we are weaving through the book that we're writing for O'Reilly. So you will see, I won't say.
Se viene un libro de O'Reilly. Saben que aquí somos fan de los libros de O'Reilly.
Like, well, you might.
Pero bueno, sigamos con este diagrama. Entonces, si por ahí ustedes se dedican a la programación o tienen algo de conocimiento sobre infraestructura y demás, es precisamente lo que mencionaban. De que ellos, la gente de Google, creó toda la plataforma de la infraestructura para poner modelos de Machine Learning en producción. Toda esa infraestructura salió de su equipo de infraestructura, no salió de la gente de que hacía Machine Learning. Entonces, de nuevo, la oportunidad está ahí. Si ustedes sienten que tienen una piedra en la cabeza para la ciencia de datos, pero le saben alguna otra parte de la programación, pueden irse acercando a la ciencia de datos por esta otra avenida. Yo tengo que entretenerme porque la música tiene copyright, entonces digo, a final de cuentas es su stream, ellos pueden hacer lo que quieran, pero yo no quiero que me vayan a bajar el video por poner música que no me pertenece. ¿Qué onda? Digo, aquí todos bien. Otro día de la conferencia, son solo 2 días. Creo que ya va a comenzar. Hoy vamos a tener que pedir pizza para cenar porque no creo que dé tiempo de cocinar.
So, we are back. What's up, Akash? How you doing? And Sheila is here too with us. Let me give you all a brief intro of Akash and Sheila, and then we can go ahead and hear their session. It is shaping up to be an awesome one. So this is a talk that is led by Etsy, and Akash is a senior engineering manager, and Sheila is a senior machine learning engineer. Akash has extensive experience with startup companies, including Uyala, acquired by Telestra, Platforma, acquired by Workday, and Quantified, and also Blackbird, which was acquired by Etsy. Sheila, who has been working on Etsy's feature stores and data pipelines at Etsy, completed her graduate studies in operational research at Columbia University. In this talk, you'll hear how Etsy uses real-time feature logging to capture in-session / trending activities, build a tight, unified feature store for sharing features across models from different domains, and serve featured data at scale with the eventual goal of powering a reactive system. Wow, that was a mouthful. I hope you guys can articulate it better than me. That's awesome. I'll leave it for you, Akash and Sheila. Thank you for joining us. I'm looking.
Sí, sí, Luis, sí, Carl Jr.
Akash, I'm here from Etsy, and here's Sheila. We both are here to talk about our unified real-time ML data pipeline and how that helps us in training and serving of machine learning models. So what's on the agenda today? We're gonna start with an introduction to.
Madre mía, es feature stores por todos lados.
We're going to talk about our unified feature store and how that's enabling a lot of interesting work. And then we're going to go into the details of how a feature logging pipeline helps with training and serving of models. And finally, some of the real-time ML applications that are enabled because of it. So Etsy's mission is to keep commerce human, and we're a global marketplace for unique and creative goods. We're a home to a universe of special items from you need.
¿Han usado Etsy por allá? Como para artistas, pero más de manualidades y cosas tejidas o pinturas y cosas así. Bastante interesante. He comprado un par de cosas.
In 2020. So I hope that gives a sense of what we're dealing with. And our job at Etsy is to connect the sellers and the buyers, so who have different passions and creativity. So buyers are coming to Etsy with a particular vision in mind, and sellers are using their creativity to provide products for that. And the question is, where is machine learning in that? And actually in a lot of places, as we will find out. As an example, if you search for planters on Etsy, you get about 300,000 results. And there's no correct answer, right? So there's a huge diversity in not only the functional aspects, so the color or the price or where this listing is from or when is it going to ship, but even in things that are not as discrete and cannot be described in a concrete, discrete label. So these could be aesthetic, style, many latent, features. And we'll see how a feature pipeline needs to account for that. The second point I'll make is that when you come to Etsy, I might like the Pokemon planter, Sheila might like the llama one. So our individual preferences are, truly what need to be taken into account. So there's a big need for a personalized shopping experience. So, so overall, what's so unique about the ML challenges here? We have about 85 million items, which are ever changing. We're driven by personalization. As I mentioned earlier, our items are not just different in functional characteristics, but also in the latent and the non-discrete space. And that's where personalization helps us show the users the most relevant items. A key piece on all of this is real-time machine learning, because a user's preferences also change in real time. I might come to Etsy looking for a particular item and then be inspired by what.
Parece ser el tema de esta conferencia, Feature Stores y Machine Learning en tiempo real.
Machine learning and personalization, these two are the keys in surfacing relevant content. And our models have to be personalized, so take into account user preferences that are changing, and real-time adapt to real-time preferences as well as aggregate trends. So we're gonna discuss how we've designed a real-time data pipeline to achieve that. And over to Sheila now.
Hi, thank you, Akash. So hi everyone, my name is Sheila. I'm the tech lead for ML Pipeline at Etsy, and I'll be going into details about our real-time machine learning pipeline solution. Well, first, I'll be talking about the feature store, which is a central part.
Feature store. Mucho feature store.
For easy scalability enforced with a type schema, which we'll talk about in just a bit. The goal of the feature store is to provide us a centralized way of storing and accessing features for training and serving purposes. There are many designs that go into this to make it easy to work with while maximizing the feature freshness and the quality, which is really important for a model training. Well, it all starts with storing various types of features. Could you go back to the previous slide? There are two major types that we consider. One is called batch features, which is generated and updated daily. The other one is called real-time features, which gets constantly updated throughout the day with often sub-second latency. Both batch features and real-time features can be aggregated over some time window, like the last 30 days or the last 30 minutes. And they can also be characteristic features, for example, the status of a listing, which can get constantly changing. So for those, we stream update into our feature store once detecting a change on that information. We made our feature store a centralized place for all features so that it can be shared across products, such as recommendations and search, and many duplicated efforts can therefore be avoided. When designing the table, we put different types of entities. For example, we have user entities, we have listing entities, and we put them in separate tables. We chose a NoSQL database for its dynamic schema and horizontal scaling. We apply the database with a logical structure so that each feature source is mapped to exactly one column family, as you can see from the graph. Each column family can house several features coming from that same feature source. This design will benefit us in many ways. The major benefit is the asynchronous feature update. Since each of feature source is grouped into a single family, updating a particular feature source is made much easier to our feature store. From the diagram on the upper right, you can see that different feature sources can get ready at various different times. Once a feature source is ready, we immediately start the asynchronous upload to update the associate family in the database. This would optimize for feature freshness and also make the on-call process easier, since each feature source can now have a direct owner for contact. The other benefit from the columnar structure is its ability to follow the typed schema we use for our features. So, well, first of all, why do we need a schema? A schema can help us in many ways, and in particular, help us automate a lot of processes and validate data for quality control. This schema we created was shared across all applications so that we were able to read and send data between different applications smoothly. On the right-hand side, we show a simplified example of our schema for a simple feature family. So the family name would be basic, and there's two features housing under the family, title and price. And from the graph, you can see how that's related with the database structure in our feature store. Adding and testing new features are also easier with the help of the schema. So to do that, we start with updating our schema with a new feature family called new family here. An automated process will then pick up the schema change and register a new family in the database sandbox for testing. Before a new feature source is uploaded, it would also be validated against the schema to avoid sending bad requests to the database. Another important automation triggered by the schema update is the feature metadata template. So this contains important information about what that feature is, what's the source of the features, name, type, the status, etc. And the developer of this feature is responsible for filling them out before officially adding the features to the store. We also expose these metadata files to a web page for increased visibility and readability for customers. As a result, our schema plays an important role to connect multiple applications and processes together. It helps make our life easier in many different ways, from database control, like the one I talk about, registering new columns in the database, to data validation, like how we are validating our data against our schema, and from facilitating feature access, some of the schema generates automatically some functions to fetch the features, and all the way to promoting documentations like the metadata files I mentioned. Now that we've talked about the feature store, let's dive into training and surveying using the feature store. Specifically, we'll be touching on feature logging, which is a solution we implemented to overcome a lot of challenges we faced in the traditional development environment. So first of all, training data is formed with two major parts: attribution labels, which can be like a purchase or a click action at Etsy. And there are also features associated with the attributions. For example, user features and listing features. So user feature in this case can be like a contextual features, and listing will be our candidate. So listing would be the candidate features. Traditionally, there are two ways to generate training data. One way is to do multiple feature source join from different places and join that together with the attribution label so that we can generate the training data. And the other one is to join with a daily snapshot feature store, which already contains those multiple feature sources, and join that with the attribution labels. So both of them are completed offline in a batch job fashion. Although it makes sense flexible for the development, it actually poses some major challenges when it comes to model training. So first of all, it creates a training serving skew due to the often inconsistent feature processing between training and serving. And secondly, it's not possible to access real-time features easily, while being more real-time is our goal. And finally, either method also poses some unique challenges like high cost for multi-joins, adding new features are difficult, like it just makes them not so ideal to solve our ML problems that we are interested in. So we introduced feature logging as a solution to overcome those challenges. The goal of feature logging is to log the exact features that are available at the inference time to train our models. By logging features in real time, we brought this offline process, like this offline batch joining fashion stuff, to online key value fetching. Moving it online makes it possible to access real-time features. This ensures us to record the most accurate real-time information available at the time of inference. Being able to generate this process on real time also enable us to get real-time training data, which Akash will talk about the applications later. The diagram shows when a request comes in, the reactive system will talk with the feature service and then pass the features to model layer. So that's the inference process. And it will simultaneously trigger a request to the feature logger so that it's able to log features through Kafka and then save it. Here comes the important part of how feature logging helps us solve the problem. So feature logging happens asynchronously right after the inference. So it's able to capture the same feature used for the inference with minimal discrepancies. Therefore, minimizing the training skew that we talk about is one of the major challenges we had.
A ver si ahorita dicen qué onda con eso del entrenamiento.
Basically, any other features available during the time of the request. For example, a user's recent actions for personalization needs. Because feature logger lives inside the reactive system, which talks with all essential services other than the feature store as shown in this graph, like candidate service, model layer, it can also log information from those services. So for example, it can log candidate information such as candidate scores, candidate sources. It can log models information like the model scores and stuff. If you have an ensemble model, it can even log the intermediate model scores and things. Plus, it has access to the request itself, so it can log request metadata for debugging purposes. So all of those informations would help with downstream analysis, and it can power many, many explainable ML applications. So both feature logger and the inferencer needs to talk to the feature store at request time. So for that purposes, we use a smart feature selector to determine the exact list of features we want from the database. The feature selector is automatically generated based on a model config or a logging allow list. The right-hand side shows an example of our allow list, where features are represented in a way very similar to our schema and to how our database is constructed. The feature selector then simply extracts this information to build a database filter shown on the right-hand side of the arrow. Schema also plays an important role in the inference and logging process. It guards against bad data when we attempt to log features to Kafka. It also generates deserialization functions and many other functions that get shared between the inference and logging process to ensure consistent data processing to further minimize the skew. Now I'll pass back to Akash to talk about real-time and personalization.
A ver si ahora sí dicen lo de con esa cosa, qué es lo que hacen con su logging.
Overview. I'm gonna dive into what this enables, particularly in terms of real-time and personalized machine learning applications. So the first one is that in-session personalization with feature chaining. So initially in my talk, I talked about how user preferences are changing in real time, and they're changing very quickly when they're on the site browsing through items, whereas listing content is relatively static. That's not changing as frequently. But there is a need to match these two, right? And we incorporate users' recent interaction and compose or combine them with pre-computed static features. And this helps us better capture what the user's shopping mission is. So we'll dive into an example of that. So an example of this is a feature where, say, we want an average embedding of the last 5 items a user has clicked. So let's first see what all is involved here. So the embeddings could be pre-computed. They could have been generated by any different algorithm and could represent a particular listing, right? So there are 80, like I mentioned, there are 85 million listings. Each has an embedding. We've generated that. We've stored that somewhere. For a user, we need their last 5 clicks. And we can collect that. We're collecting event data, and we need to combine those two now. And the aggregation function is how we help combine that. Now, why are we doing this? Traditionally, the listings, the embeddings only represent the listing, but we would like to incorporate users' recent information to also represent the user in the same embedding space. And this is extremely powerful because then you can better match the users and the listings that best serve their needs. So an example architecture is that users' clicks are coming into the site. We have a streaming service that's ingesting all those events. We're chaining or we're composing those with pre-computed listing features, and then we're getting chained features. So more concretely, we get the last 5 items of a user. we combine those with the embeddings to get the average, embedding of the last 5 items. And that becomes an input into our personalized ranking model. And of course, we're using the other, features from the user feature store or the query or listing feature store that we've talked about. But by doing this training, we're able to like incorporate the composed features and combine real time with pre-computed features. Moving on to the second application of real-time feature logging is drift monitoring as well as validation. So because we're logging our features from the reactive system in real time, as Sheila mentioned, we have built a simple Kafka Stream application which can ingest these feature logs. And this is extremely powerful for validation purposes. So by logging these features in real time, we can see, is there any error in those feature logs? Are we adding some, are we missing any values? Are the feature values out of range? So we can catch these bugs or errors, any distribution outliers very quickly. Our teams can react and we can fix the pipelines very quickly. But one of the applications which we're starting out with and which we're very excited about is this feature data monitoring and drift monitoring. So understanding the feature distribution and how they're changing on a day-to-day, and being able to explain our models with it, that's like a key here. And that's where I think a lot of explainable AI systems can also plug in, and they can ingest this real-time data stream. Cool. Okay, and moving on to actually my favorite application of the whole real-time ML pipeline, which we've started on, is a bandit application. So traditionally, multi-arm bandits are used to dynamically allocate site traffic to different variants. So what do I mean by that? I basically mean users are coming into the site, and we can use static A/B tests traditionally to figure out, oh, do we show them bucket A or bucket B features? But in a multi-arm bandit, we can dynamically adjust it. We can say today 40% will see this, tomorrow 50% will see this, and we can adapt to their needs over time. These bandit applications are very useful and powerful for in search and recommendations land. Particularly in candidate selection and ranker model selection. We'll talk about candidate selection just now. A key thing here is that contextual bandits are even more powerful because they take into account the real-time context. They're not learning context free. They're not learning a global setting, but they're able to incorporate what this user wants, what's available in real time. And that really helps us, serve them even better. So we'll see that in an application. Okay, so diving in. So
Pues por lo visto nada de reentrenamiento en línea.
Candidate selection. So we have different candidates. So we have visually similar listings that have been purchased together, or TF-IDF listings. So these could have been generated with different algorithms. So like visually similar listings have been generated with embeddings. Co-purchase listings have been generated through, co-purchase matrix or count. TF-IDF, traditional information retrieval. So these are candidate sets, and concretely, they are a pre-computed list, right? So you're saying for user A, these are the top 100 candidates. For the user B, these are the top 100 candidates. So you have these candidates pre-computed. You have a second pass ranking model, and this ranking model can rank these listings. So it can tell you, hey, if I give you top 100 listings, which ones to show to the user. Now, what we would like to do is figure out what is the combination of this candidate set that we need to surface to our users. And specifically, we don't want to just come up with one global combination. We want to be able to do it at the user level. And that's where contextual information comes in. So this is where a contextual bandit system helps us, where we're going to fetch the user features from the feature store, which becomes a source of contextual information. We're going to fetch real-time streaming features, which also becomes a source of contextual features. So that's similar to the chained features I just talked about. And how are we learning this bandit? So if you look on the left, we're getting the attribution events, which are the clicks, cart ad, or purchases. And then we're getting our users' queries, which are the ranking models. And so based on those, we're able to log our features, we're able to get our attribution events, and we're able to learn this mandate to best learn the, what are the candidate set combinations. So yeah, that's a simplified view or a high level view of how we're using contextual bandits for candidate selection problems. So to summarize, there are many applications of our pipeline, starting from sharing of features.
Parece ser que sí tienen algo de entrenamiento, pero no hablaron tanto de él.
Real-time data validation, which I talked about, like especially explainable AI as being one promising one. In-session personalization being like, personalized features such as change features, training models across products. So that's something which I didn't dive into, which is that you can share, because we have a standardized schema, we can share our training data between different models. And the two of the future applications, one of which we dived into was contextual bandits. So how we're using contextual features to serve, personalized candidate sets. And one really promising one in the future is online learning. So because we're logging our features and our attribution data in real time, we can now update our models more frequently. So hope this was a great summary.
Estuvo un poco, no sé, muy pesada. Pero bueno, ahí está. Feature logging. Usualmente para lo que se utiliza el feature logging es para una de las aplicaciones que mencioné ahí, que es monitorear cómo es que se va comportando tus usuarios o las entradas a tu modelo. Para mantener tu modelo sano. Pero no puede empeorar el bias en eso. El mismo modelo. ¿Cómo? ¿A qué te refieres? Bueno, algo que se me ocurre que podría pasar ahí es y crear un feedback loop. Pero ¿por qué?
Get stored is passed.
Excellent. So another one for you, Sheila. So the stream and batch jobs load the data into a single database that users read from to retrieve their features for both online and offline workloads. What database are you using?
Okay, interesting question. So the database definitely gets both real-time features and batch job uploads. But the way to access those features currently are only online, like through online inference or online feature logging. In terms of the database that we're using, I don't know if I can say it, but currently we use Google Cloud Bigtable. Yeah.
All right. And if you can't say it, we can edit that out later. Don't worry. Just tell us. No problem. So there's.
Sí, bueno, para aplicaciones de online learning creo que es precisamente que se utiliza online learning, porque tienes la expectativa de que tu modelo necesita ir cambiando constantemente e ir moviéndose con la información. Entonces se tiene ese bias del que podrías estar pensando, me parece que es un una característica, es un feature, no es un bug de los modelos en online learning. Y por eso es tan importante encontrar encontrar el problema adecuado para atacar con un método de online learning. Porque digo, se oye muy bonito, ¿no? Aprender online, hacer un online learning, pero en realidad no es algo que necesites hacer para todos los modelos de machine learning. Tienen sus usos específicos.
Have experienced due to computational complexity of contextual bandits in real time.
I mean, definitely, it's a very big task to monitor them, and that's what we're like excited about. Like, it's just the replayability of this is actually a really big challenge. That how will you? It's an online system which is going to learn in real time, but you also, how are you going to learn the policy per se offline? That's where a lot of the challenge is. So it's not just as much about like enabling it in production, but also like being able to learn that and observe that. That's where a lot of the investment goes in.
Excellent. Okay, I lied. There's one more, and we still got a minute, so I'm going to ask it because people have been loving this talk, as of course they would. This has been super informational. Mike's asking, how do you manage cost attribution, and or do you do that at all?
We definitely are managing. So one of the things about having a centralized feature store is that we have individual feature owners. So that's on the feature generation side, where we can see like which team is generating the features. But I think the question, if I'm understanding the question, the real point of the question is that, you're building a lot of these things once, and then you're trying to add, you utilize them in different models. So the cost is then shared across those applications. We've made some efforts on attributing and understanding it fine-grained. I would say that we're not as fine-grained as we would like to be, but we're definitely on that path. Yeah.
Yeah, asking about the dollar cost.
Okay, eso está muy chido. Pues sí, entre más aplicaciones de machine learning tengas y puedes compartir los features entre ellas, más barato te sale juntar los datos. Bastante, bueno, no lo había pensado de esa manera. Pero sí, bueno, volviendo a lo de online learning, es un poco complicado en explicar principalmente a las personas que no tienen mucho conocimiento de data science, porque piensan que el online learning es como la evolución natural del machine learning, del batch learning, cuando no es así. Son dos cosas, sirven diferentes propósitos. No es así como que digas, ya tengo este modelo que está aprendiendo en batch y el siguiente paso es moverlo a online learning. No. Tienes que tener la necesidad real de que tu modelo tenga que aprender en tiempo real. Si no, de otro modo, seguirlo entrenando en batch es más que perfecto y pues es inclusive más barato y pues mucho menos complejo. Me acuerdo que mis compañeros que igual no conocían mucho de machine learning, les presentaba un modelo. Y siempre la pregunta obligada, la pregunta principal era, ¿y qué pasa si lo ponemos a aprender en línea? Y obviamente la calidad, digo, dependiendo de lo que quieras lograr, pero yo les decía, no necesitamos que nuestro modelo aprenda en línea, estamos recibiendo productos, no sé, estamos recibiendo entradas solamente durante la noche o a lo mejor las tendencias que estamos tratando de analizar no cambian en cuestión de horas, no cambian en cuestión de días, a lo mejor cambian cada 6 meses, cambian cada año, entonces definitivamente no necesitas online learning para esos casos. Por más bonito que suene, por más interesante que suene, de nuevo, no es la evolución natural de un algoritmo en batch learning. De un modelo que aprende en modo batch. No sé qué tan buena vaya a estar esta plática. no le tengo mucha confianza a Deloitte.
For the next session, gonna be having a lot of people in this session. Exciting to present it. The team from Deloitte and Diego from Algorithmia are teaming up.
¿Qué onda, Alonso? Aloncello. Como que ese es cello del instrumento. Yo lo veo en robótica y solo en ciertos casos. Sí, digo, para robots, por ejemplo, un robot que pueda ir aprendiendo sobre el terreno, a lo mejor eso, ahí tendría mucho sentido utilizar online learning. En lugar de, no sé, entrenar el robot en una cantidad de terrenos diferentes, por ejemplo, puedes entrenarlo en un terreno base y que el robot vaya aprendiendo de las características del terreno. Entonces ahí online learning tiene como que mucho sentido. Saludos, saludos. De veras, ahorita voy a ir por una chela, porque desde ayer traía ganas de tomarme una. Ahorita voy a ir por una.
Customer experience platform goes. I'm pretty excited for it. I hope you all are too.
Y un paper en donde el robot aprendía qué era. El robot ganaba conciencia. A ver, voy por mi chela. Les digo, no sé qué tanta confianza le tengo a esta plática de Deloitte, pero bueno, vuelvo rápido.
Here real quick, and let's start up. Really excited to be talking to everybody today. Can I get a thumbs up for anybody? See my screen? Make sure we're all good here. Great, excellent. Oh, yeah. So super exciting talk, today. Really excited to introduce Julian and Paul. They've been doing some really interesting stuff in the machine learning space, especially when it comes to customer experience. And in particular, one of the things that I'm particularly excited about what we're talking about today is a really interesting methodology on how to actually build out a platform, what to optimize from kind of like cost and thinking, and the importance of operationalizing ML, but not just operationalizing it, but actually making it sense from a cost per action perspective, and tying it together to how do you actually go and build these platforms, operationalize them, run them at scale. So with that said, I'm going to pass this on to Paul, who can lead us off here.
Thank you very much, Diego. That's fantastic. And, big welcome to everybody. And thank you for attending our presentation. I am the CTO of a team in Deloitte that is responsible for building a CX platform to sell to large enterprises. The mission is to deliver an end-to-end capability to large enterprises, which offers very short time to value.
Entonces el robot, bastante interesante. Si tienes el paper, estaría chido verlo para ver si utilizaba online learning.
Be engaged in hardcore engineering. So I think that's an interesting, part of this, presentation in its own right, because there are lots of things going on in the market that are actually forcing us to engage in, hardcore engineering now in a way that perhaps, as a firm, we might have been slightly less interested in the past. But, I'm just going to set the scene. I'm going to talk a little bit about what an end-to-end CX platform looks like.
A tu salud, Aloncello. Una porter.
That platform. And then I'm going to pass to Julian, who is our lead on, decision automation, and he can talk more about some of the challenges that he's faced. But just as a backdrop, if you consider our large clients, we're in a very interesting time now. There are, technology continues to advance particularly quickly, but I think in the place of, or in the domain of machine learning, some of those advances over the last even 5 years offer potentially very large performance and efficiency gains. And what we see is that large enterprises are really just struggling to implement those things. And why is that? Of course, it isn't anybody's fault. It's the fact that those large those large tech stacks, so those enterprises, they've evolved organically over many years. They are trying to service large numbers of teams with different applications. You have individual teams making their own choices about such technologies, though there are often duplication and overlap. trying to deliver those services across, a wide range of devices. And unfortunately, it just means that those stacks, they have a lot of undocumented dependencies, and it's just hard to swap out any component that you may want to swap out. The result then is that those enterprises are finding it hard to and they're kind of sitting there seeing some of these really potentially dramatic improvements in performance, offered by these technology components kind of disappearing over the horizon. So how do you address that problem? And that's what I'm going to talk about. And this is really what we have been building internally. But before I do that, I just want to look at, what is an enterprise CX stack, and, what are the pieces we care about? I'm going to focus on, the part here that we most care about here, this audience, but I think it's just good to put it in context. So just looking at the left-hand side here, basically we want to connect with as low friction as possible to any and all data sources that we believe are going to help us characterize the relationship between a consumer and a brand. And that's going to be everything that you might expect, like campaign history, any interaction from a consumer to the brand, whether that's web, whether it's an app, whether it's through the store, call center, whatever it may be. And we may also want to connect to external data sources. And increasingly, it may be things like we want to supplement our ID graph with an external party. We may want to get, for example, brand market share in a DMA or a market area, because that helps us carry.
Si ustedes como yo no tenían idea de qué significa CX, significa Customer Experience, según.
Some kind of customer data structure. We, in fact, use a Snowflake, and have been on Snowflake for a couple of years now, and I think it's turned out to be a really good choice. One of the big themes inside that customer data management structure has been ID resolution, in significant part driven by machine learning requirements, where we want to make decisions at individual consumer level, typically or often in real time, taking into account particular contexts. So ID resolution has become a particular theme. If we just move to that middle section, which is possibly the most interesting for this audience, a very significant theme here has been, if we look at historically how customer data has been structured, it's been primarily structured to support.
Y aquí está la cajita de siempre. Feature Store, supongo que va a hablar de Feature Store.
59% of operational IP in large enterprises, so the people that are pulling the levers to change things, resides in the minds of humans. And so not surprisingly, being considered the primary use case for customer data up until relatively recently. What we're now seeing is a requirement or a desire of large enterprises to move that operational IP from effectively the minds of humans or the control of humans to automated processes using machines. And so suddenly we have this requirement where we need to structure data natively to support machine learning in ways that people never really conceived. A lot of the requirements for machine learning then are being pushed back on legacy infrastructure that was never designed to actually support it efficiently. So now consider we have that block here that I've called MLOps, so where we've got some kind of native preparation of data for machine learning, which is of course feature stores. And we want to create
Feature stores again.
Where so we can develop our models with the same tooling and data environment as we have for production. And obviously that then allows us to use traditional CI/CD mechanisms where we can promote models and pipelines that are being created in dev straight into production, and we know that they're going to work. The next section is that marketing orchestration. We want to then get that intelligence into orchestration systems, interact with consumers, and we want to feed that background on the left-hand side. One of the themes there is latency. So just consider that we want to take into account data and interactions that may have occurred with that consumer on the left-hand side, and change the way we interact with consumers on the right-hand side, perhaps with a latency of less than 50 milliseconds. So this is a real end-to-end architecture we have to think about here. Thanks, Diego. So, other things to consider as a backdrop, which make it very hard for CMOs, who are the typical owners of customer experience, to put this in place. They have a very low tenure. They have the shortest tenure of the C-suite. There was a report in May of last year in Wall Street Journal saying actually that the median tenure of a CMO was unfortunately only 30 months. If you consider the breadth and complexity of putting in place CX changes with technology, 30 months isn't very long. And then
Se me ocurrió hacer un meme para poner en el Slack de la comunidad. No me suena que sea el PDF original, pero algo es algo. ¿Por dónde lo vas a pasar?
All thought that their CMOs were not performing well. That's a horrendous statistic, which tells you really they probably don't even have the authority often inside the enterprise to really enact what they need to do. So look, it's a very challenging space. Just a couple of other things I would say there. Obviously, interactions with consumers, the number of channels, it's exploding, becoming more complex every day. Along with that, tracking complexity is being made more difficult across especially third-party tracking. So attribution of value is becoming harder, and it's very hard for our large enterprises often to actually recruit top engineering talent. The digital hyperscalers, of course, and often West Coast startups and other technology startups are more attractive often, so they may not have the resources either. Thanks, Diego.
No sé si lo puedes poner ahí en el Discord. Y ahorita lo abrimos. Porque bueno, de nuevo, les dije que no iba a estar tan buena esta plática. Nunca espero cosas tan buenas de Deloitte. Así que si ustedes ven acá arriba a la izquierda, me puse a hacer un meme de Feature Stores. Nos lo podemos hacer aquí rápido. Igual cuando ustedes van a conferencias, pues no van a todas, ¿cierto? Así que hagan de cuenta que nos estamos tomando un break ahorita. Entonces vamos a hacer este meme y lo vamos a publicar ahí en el Slack de la comunidad y por supuesto también en Twitter. Damos generate y le damos save image as, lo guardamos. Ok, no, ya vamos a ver el paper.
Of technology in a seamless way. And of course, inevitably, the latest technology, if you want to use some of the highest performing technology, it's going to...
¿Algunos de ustedes que están viendo esto trabajan en Deloitte? No quiero ganarme enemigos nuevos. No tengo las mejores referencias de Deloitte. Entre mis amigos y conocidos que han trabajado ahí, como que no existen las mejores referencias. Pero bueno, de nuevo, eso son solo anécdotas.
CX. We're very careful.
Ok, está hablando de cómo calcular el costo de un sistema de machine learning.
Software costs. And we're trying to calculate, given where that enterprise is today, what is the fully loaded cost per action? And if we do it using the best technology, and in this case, a pre-built architecture, what do we believe we can get that down to? So a lot of the focus of development for us has been, how do we take cost out of these decisioning activities? And you can do that fully loaded cost at a higher level. So for example, how much does it cost to build, deploy, maintain, and govern a particular machine learning pipeline for a year? That is an action, but you can also calculate it at the individual action level. And then compare that, if you like, to the revenue performance lift that you get by taking that action. And of course, we want to have a nice positive outcome there. Thank you, Diego.
And I think that this is, super interesting because, in the crowd here, there's a bunch of ML engineers, and, so optimizing functions is probably exciting to pretty much anybody involved. This is one of the first times that I've seen, kind of thinking from an architecture perspective. And
Acaban de banear a la Universidad de Minnesota por poner parches vulnerados a propósito del kernel de Linux, solo para ver qué hacía la comunidad. Metieron parches al kernel, al kernel original del Linux. Dios mío. ¿Por qué estaban pensando?
to the minimum necessary. I think it's a really interesting approach to kind of large scale ML system building that not a lot of people have been thinking about. It's usually let's piece together these components, but not think holistically cost per action through the whole thing. So I know I got really excited when you were sharing how you and Julian kind of had to piece this together.
Yeah. Again, Diego, you raise a great point. One of the things that we'll find is the financial systems and the tracking systems of activities are insufficient to track this in large enterprises today. So that's another theme that we're actually looking at internally, is making sure we have the financial and activity tracking metrics that allow us to get to those numbers on an ongoing basis. Yes, I know that's another background theme. We're not there yet, but it's coming. Next slide. Thanks. So look, the last thing is, we're saying we're kind of mapping, the impact of certain types of technology. And I'm sure.
Y los banearon y se indignaron y todo, pero hasta paper sacaron de ello. Sería bueno leer ese artículo de Linux. Vamos a ver de qué demonios. Con esta gente está hablando de precios y demás, que digo, son importantes, pero la verdad es que no venía yo con intención de leer esto, así que vamos a ver. Primero vamos a ver Task Agnostic Self-Modeling Machines. Ese es el paper que compartió ahí Totón en el Discord de la comunidad. Ya saben, tcsg.dev/Discord si quieren entrarle. Y bueno, dice un robot se modeló a sí mismo sin conocimiento previo de física o de su forma y utilizó self-model, no sé cómo traducirlo, para realizar tareas y detectar daño a sí mismo. ¿Con qué intenciones venía ahí? Para aprender de MLOps. Y bueno, ahorita esta gente está hablando de costos y cálculo de costos, supongo que de sistemas de machine learning. De nuevo, no era mi intención el día de hoy, así que vamos a seguir viendo este paper mientras esa conferencia sigue. Porque bueno, igual vinimos acá a platicar un rato para que no nada más nos estemos pirateando el stream de... Que bueno, la conferencia es gratis, por cierto. Y estuve platicando con el organizador que estaba haciendo esta retransmisión y a él no le importó. Me dijo que me iba a ver, entonces saludos si me estás viendo. Vamos a tratar de encontrar. Primero vamos a hacer lo obvio. Vamos a buscar Machine Learning. Aquí está. Digo, no es la forma ideal de leer algo, pero vamos a encontrar directo al grano por el momento. Los humanos usualmente adquieren su imagen propia temprano en su vida y se adaptan a ella continuamente. Sin embargo, la mayoría de los robots actualmente no pueden generar su propia imagen, es decir, supongo que no pueden ser conscientes de sí mismos. A pesar de que los recientes mejoras en Machine Learning han permitido que los robots se conviertan más y más, aprendan más y más a entender el mundo alrededor de ellos. Cuando se trata de entenderse a sí mismos, muchos de los robots todavía tienen que están hardcodeados para realizar esto. Una alternativa al automodelado, muchos sistemas robóticos lo hacen sin ningún modelo, usando entrenamiento de principio a fin por una tarea específica, aplicando técnicas como reinforcement learning, o sea, machine learning, task specific learning, Y bueno, eso se trata de una cosa que se llama Narrow Artificial Intelligence, que es solamente aprender una tarea. Lo contrario a Narrow Artificial Intelligence es los famosos AGIs. Parece que es Artificial General Intelligence, que bueno, también, no sabía que se llamaba inteligencia artificial fuerte, que bueno, consiste en un sistema que funciona como el cerebro humano. Bueno, el cerebro humano es de propósito general. No solamente está diseñado para realizar una tarea, sino que podemos aprender muchísimas tareas a lo largo de nuestra vida. Este AGI es a lo que mucha gente le tiene miedo, que de repente una máquina pueda ganar conciencia de sí misma y tenga la capacidad de aprender tareas para las cuales no fue entrenada. Entonces, bueno, ya saben, lo contrario a esa super máquina de inteligencia artificial son los Narrow Artificial Intelligence, que bueno, vamos a ver si encontramos a qué se refiere. Vamos a ver. El Intelligence, vamos a ver si tiene una traducción al español. No, bueno, inteligencia artificial débil. Artificial Narrow Intelligence, que es lo que estaban aprendiendo los robots, también conocida como débil, es la inteligencia artificial que existe en nuestro mundo actualmente. Así es. Que está preprogramada para desarrollar una y una sola tarea. Aquí dicen como por ejemplo checar el clima, aprender a jugar ajedrez o analizar datos e información para escribir reportes. Pero bueno, volviendo al paper. Falta de generalidad y para los robots continuamente aprender nuevas tareas durante sus vidas. Aquí sugerimos que, porque dado que el robot propio es persistente a través de múltiples tareas, hay un fuerte incentivo para extraer un automodelo y que podemos reutilizar este modelo para repetidamente aprender nuevas tareas. Entonces me parece que este es como que un intento de llegar a esa inteligencia artificial general. Y bueno, lo que dicen es que no importa las tareas que esté realizando este robot, el robot siempre permanece, es constante. El mismo robot va a estar realizando diferentes tareas. Algorithms to find the morphology consistent. Estaban utilizando algoritmos genéticos, bueno, evolucionarios. Pero bueno, lo que estaban buscando es si un robot puede aprenderse a sí mismo, tener conciencia de su forma, supongo, sin conocimiento previo. Pero bueno, aquí está por lo que venimos y lo que mencionaba Totón. Utilizaron un modelo de machine learning, bueno, en específico, de deep learning, aprendizaje profundo. Ok. Digo, como tal, sí, machine learning. Deep learning en específico, ya saben, deep learning es un subcampo de las redes neuronales y las redes neuronales es un subcampo del machine learning. Sí, siguen hablando de las cosas. Pero bastante interesante esta Totón. Bueno, sí, me sorprende que muchas veces se hablan de robots y lo primero que se les viene a la cabeza a la gente son esos robots de Boston Dynamics que te pueden destruir o que caminan. Usualmente las pruebas las realizan con ese tipo de robots que son como un solo brazo. Obviamente esto es irrelevante, ¿no? Pero porque de aquí se puede trasladar a otro tipo de mecanismos. Es bastante interesante cómo la gente se imagina lo peor de entrada y tal vez lo peor esté por venir, pero muchísimos de los experimentos se realizan en este tipo de robots, de máquinas. Y bueno, vamos a ver a la Universidad de Minnesota. A ver, Minnesota, Linux. La Universidad de Minnesota ha sido baneada del desarrollo de Linux por introducir vulnerabilidades. Vamos a leer el artículo de Ataca. Ataca, no sé. Ok, disagree to. Dios mío, qué desastre. Pero ¿por qué se les ocurrió eso? El motivo es el trabajo de investigación que estaba realizando Gu de doctorado sobre la habilidad de introducir sigilosamente vulnerabilidades en el software del código abierto. Pues no fue tan sigilosamente. Le falló la parte del sigilo. Los investigadores intentaron poner una vulnerabilidad de tipo use after free en el kernel de Linux, entre otros commits. Desarrolladores más importantes. El kernel haya decidido banear por completo a toda la universidad, no solamente a esos 2 desarrolladores. Algo que la propia universidad ha confirmado. Les costó caro el asunto. Pero bueno, supongo que lo estaban haciendo con la ciencia enfrente, ¿no? No tenían no era algo malicioso, pues, a eso me refiero. Y bueno, aquí me fascina mucho leer este tipo de documentos. Tienen como que una estética retro, bastante interesante. Y aquí está, por ejemplo, se estaba... no sé por qué me fascina. Pero bueno, aquí le dice que le pide a Greg es la persona que los baneó, que deje de acusarlo, que casi está cometiendo un crimen al acusarlo de, supongo que de poner esas partes del código. Aquí dice que los parches fueron enviados como parte de un nuevo analizador estático que escribió. Y bueno, dice que lo que hizo no era con intento malicioso, no traería un propósito mayor que querer contribuir al código, pero le salió mal. Digo, si no lo hicieron a propósito, esto hace parecer que como si no supieran qué demonios estaban haciendo. Pero por eso me sorprende. Digo, de nuevo. Si lo hicieron a propósito, me parece que este correo solamente lo está exagerando, porque bueno, aquí como que se está victimizando un poco. De nuevo, no sé el contexto general. Pero bueno, ok, aquí está la clarificación. Tú y tu grupo han admitido públicamente enviar código con bugs o con errores para ver cómo la comunidad reaccionaría y después publicaron un paper basándose en ello. Ok. Me fascina cómo también para hacer énfasis utilizan el guión bajo. Y bueno, ya aquí está todo el intercambio de correos. Pero sí, me parece que esto ya estuvo como que de más. Se estaban victimizando de más y bueno, creo que no era y bueno, aquí está su cochino paper. Y bueno, aquí dice, como analizando las posibilidades de introducir vulnerabilidades silenciosamente en código open source, en aplicaciones open source software, pues, utilizando commits hipócritas. Y bueno, como tal es todo un paper. Supongo que habrán puesto ahí que los atraparon. Vamos a leer el abstract. Déjenme ver cómo va la conferencia. Ok. Y siguen hablando de los de Deloitte. Semantic Operation correct. Esto es algo que se me hace ridículo. Digo, no tengo ningún... no tengo ninguna experiencia con publicando papers ni nada, pero me parece un poco ridículo que hayan puesto esto de acá abajo. Digo, no lo he terminado de leer, lo acabo de abrir. Pero esto es ridículo, ¿no? Que proponen cómo es que pueden mitigar este tipo de ataques con cosas como actualizar el código de conducta del código abierto. Esto es algo ridículo, ¿no? Supongo que, de nuevo, alguien, demonios, odio decir sentido común, pero un buen desarrollador con sentido común sabría no hacer eso, ¿no? Entonces se me hace algo un poco ridículo, pero bueno, es su paper, qué sé yo, ¿no? En este paper nosotros en lugar investigamos la posibilidad de introducir código inseguro de una perspectiva crítica. Es horrible y sí, ya quedaron manchados en Linux de por vida. Y lo que se me hace más extraño tal vez es, digo, de por sí ya estaban jodidos, pero después tratar de presentarse como víctimas en este correo creo que estuvo de más. Vamos a ver cómo va mi meme. Ok, el senpai presentador senpai acknowledge me. Vamos a ponerlo por acá. Vamos a publicarlo aquí. Y ahí está. Y bueno, ¿qué era lo que se hacía por acá? Pero la
Own data
plática creo
assets.
que
So I'd say
sigue.
that's a very big theme out there, right?
Pero siguen la presentación esta que no tenía traía mucho poder. Dando OpenAI. ¿Para qué? Para hacer el commits maléficos, maliciosos. Y bueno, por ahí. Ya llévame, Kobe. Pero igual hay... Oh, Dios mío. Ok. Se ve un poco creepy ese robot. ¿Cuánto costará? ¿Lo llevarán en una caja o lo sentarán en un asiento de avión? Referencia más magistral. The man who made a copy of himself. Director de Laboratorio de Robots Inteligentes de Osaka. Se ve... ¿Han oído ustedes hablar del Uncanny Valley? Vamos a ver. ¿De qué va esta? A ver qué es lo que me parece que hay un break.
Then we're going to be hearing from Lack. Oh, man, Lack, I'm excited to have you come on here. But before you jump on, Lack, we've got 5 minutes, I think, and I'm going to explain how people can win some of these flashy algorithmia bottles or some of the I think there's a Tecton bottle and a Fiddler AI bottle, and there's also Monte Carlo.
A ver si me dan algo por mi meme. El Valle Inquietante en español. Sí, no sabía que así se llamaba. Vamos a ver. Ah, demonios, tengo que cambiar mi meme a que sea apply meme. A ver. Vamos a tuitearles. L. ¿Qué demonios? ¿Dónde está? Dios mío, no creo que esté ando aquí. A ver si me dan por fin algo de swag. Deberían seguirme en Twitter. Digo, tuiteo puras cosas. Shitposting, ya saben. Eliminar este de aquí. Y vamos a retuitearlo con apply meme. Y los vamos a MLOps community. Y ahí está. Oh, demonios. Muy rápida. Dios mío, creo que la cerveza. Ahí está. No te preocupes, vamos a intentarlo de nuevo. Twitter no te deja poner dos mensajes similares uno tras otro. Vamos a tener que cambiarlo. Demonios. ¿Cuántas cervezas les toma a ustedes para ponerse un poco afectados? Ahorita vamos a seguir con la conferencia, no se preocupen. Estamos en break. Por eso que estamos tuiteando. Lo que estamos viendo, así Hiroshi Shiguro. Pero sí, por ahí Totón decía que el viaje inquietante es el famoso Uncanny Valley. Uncanny Valley. Que bueno, trata de precisamente aún muchas de las cosas que salen del Uncanny Valley son precisamente robots que tratan de simular humanos. Bueno, vamos a ver en español. Bastante creepy. Yo lo traduciría como el Valle Creepy, algo así, pero se llama Valle Inquietante. Que bueno, de nuevo surge del campo de la robótica como tal. Bueno, se afirma que cuando las réplicas antropomórficas se acercan en exceso a la apariencia y comportamiento de un ser humano real, causan una respuesta de rechazo entre los observadores humanos. Algo entre más se parezca a nosotros les causa rechazo, ¿no? Por ejemplo, si van a un hotel y los recibe esta dama robot, como que lo saca de onda, ¿no? Un 6 de artesanales, o 12 Coors Light, o 30 Miller, o 8 negra modelo. Me late que tengas diferentes medidas para diferentes tipos de cerveza. Ok, esta plática va a estar buena, ¿eh? Estos monos escribieron un libro, ahorita traigo el libro, pero esta plática va a estar muy buena, espero.
So, while we're waiting for Lack to jump on here. I'm going to give a little intro. And, oh, actually, I have Lack's book here. Hold on.
Va a enseñar el libro o les hablo.
I don't know if anyone can see me because there's a screen being shared here, but Lack and a few other bright folks at Google wrote this incredible.
Creo que igual ya les había hablado de este libro en un en vivo.
It is called Machine Learning Design Patterns. I highly recommend that you check that out if you have not. It is an awesome read. Great to just familiarize yourself with everything that's going on. They talk a lot about feature stores in this and go into a deep dive on Feast too. So, Lack, are you around? I hear you. I think.
Yep, I'm here.
There he is. All right, cool. Let me introduce you to real fast.
El micrófono está altísimo.
2 people out there that do not know you and have not read your book. Let's go. Lack is the director for data analytics and AI solutions on Google Cloud, where his team builds software solutions for problems across industries. He also founded Google's Advanced Solutions Lab, ML Immersion Program, and is a published author, as I mentioned before. Get this book. Before Google, Lack was a director of data science at Climate Corporation and a research scientist at NOAA. Today, he's going to cover 3 patterns that are useful in creating large-scale and resilient data and ML pipelines. These patterns provide you a way to apply hard-won knowledge from hundreds of ML experts to your own.
Les juro que va a hablar de feature stores.
And I still don't think I can see you, so you might have to turn on your camera if it's possible.
Okay, I am, but the host has stopped it. So waiting for the host to let me start my video.
we cut you off, Lack. I'm sorry.
Yes.
Uh-oh. There
Absolutely.
he is.
Now I'm here.
There
Yeah.
he is. And if anyone
I
really wants to hear
Demetrius, I love your new look, by the way.
Thanks, man. That's great. I was going to tell people too, because we were asking the question in the poll, should a data scientist learn Kubernetes? And if you really want a good answer on whether or not a data scientist should learn Kubernetes, go check out the video Lack and I did for the MLOps community. That is a brilliant reason why a data scientist should not learn Kubernetes. And that, with that, I'll leave it for you, Lack. Take it over.
Okay, aprendamos Kubernetes.
We're going to have this next talk in Kubernetes, and I just had to jump in and tell you what my opinion was on the whole Kubernetes thing around data science. But today I'm not going to be talking about Kubernetes. I'm going to be talking about machine learning design patterns that are useful for data engineers. Okay? So what exactly are design patterns? These are things that are pretty familiar to software engineers, right? These are formalized best practices for problems that happen over and over again. And now that we've been doing machine learning in production for several years now, we have built as a community a lot of experience in terms of what actually works in terms of machine learning. And we thought that this was a good time to basically start recording some of these best practices, because if you're new to the field, you don't know that this is the right, these are things that people have tried before, and here are the trade-offs, and this is why you use what you're using, the things that some of the names might appear in the APIs, but you might not realize the reason why you're doing things in a certain way. So knowing the design patterns, having names for them, really helps you become a much better machine learning engineer, because much better data engineer. So what we did was that we captured 30 of these design patterns in this book. And what I'm going to be doing in this talk is that I'm going to be talking about 3 of them: transform, stateless serving function, and continuous evaluation. Now, in addition to the book, there are example implementations of all of these design patterns in this GitHub repository. And so I really encourage you to go look at the code to give you an idea of this is how people actually implement this in real life. So what I'll be talking about here are primarily about the concepts, but these are all very, real and implemented and part of many production ML projects and things that are used by a lot of teams. So let's start off talking about the transform design pattern. This is design pattern number 21 in the book, 21 out of 30. Okay? And let's kind of frame why we need this in the first place. So imagine that we have a machine learning model and it's going to predict the length of time that somebody is going to keep a rented bicycle. So they rent the bicycle at some particular station, let's say King's Cross station in London, and they rent it on a specific date. And we want to be able to predict that if they rent this bicycle on April 22nd, 2021, right, and they rent it at King's Cross, how long are they likely to keep this bicycle around? This is going to be important because we want to stock bicycles. We want to know when to do maintenance on the bicycles, et cetera, et cetera. So in order to do that, we train an ML model. And the ML model basically takes a station name, it uses it as an input, and when we give it April 22nd, 2021, it pulls out Thursday and it pulls out the hour of the day, pulls out, let's say it pulls out 18Z, right? In London. That's the time that it pulls out. And it goes ahead and trains an ML model to predict the duration. Okay? So that's basically what we have. We have two inputs, station name and start date. We have three features that we have into the ML model, right? We've pulled out the day of the week and the hour of the day from the inputs, and we use it to train an ML model. So this is great. We trained the ML model. The model now basically works, and it's basically, we take that model, we deploy it, and now we want to run this model in production. What inputs does the model want? Does the model take the station name and the start date, or does the model require station name, day of the week, and hour of the day? It's pretty clear the model was trained on three inputs. So it's going to need three things, which means that this poor client here has to somehow know what the model developer did in pre-processing and feature creation in order to call this model. And this is a huge problem. This is what leads to training serving skew, because the model developer might have done everything in Python, and now we have to basically go find the equivalent thing in Java or JavaScript or whatever it is that we're going to be doing on the prediction system side to pull out the day of the week and the hour of the day, right? So the problem here is
la conferencia literalmente va a durar 6 horas.
The week and the hour of the day from the data, and we've trained the model with 3 inputs, which means that whenever somebody calls this model, they have to know, okay, King's Cross is a station name, but they have to know that in the training system, Thursday was represented as 3, right, in quotes, as a string. How do I know that? How do I get a library that gives me that? And that is a...
I'm not sure if this one's pre-recorded, this specific talk, but I don't think it's pre-recorded though.
You can do and say, this is BigQuery ML that I'm showing you. It's a SQL way of doing ML models. And the idea is that even though you pulled out the duration, which is the label, the start station name, and the start date, those are the inputs, you now basically say that the model needs to transform. And what it needs to do is to take the start date and extract out the day of the week and the hour of the day, and then train the model with the duration as the label and 3 inputs. And now that the model is trained in this way, we've kind of kept the inputs and the features separate. And that means that when we go ahead and do a prediction, it's as easy as saying King's Cross and the current timestamp. And the model, internal to the model, it has captured all the pre-processing and feature engineering that has to be done on the input data to get to the model. So as you can see, this becomes a lot simpler from a productionization standpoint if we take the transforms and we put
Esto es bastante interesante porque, bueno, ahorita está hablando de BigQuery, ML y SQL, que bueno, no es tan popular. Pero bueno, la idea es que cuando ustedes entrenan un modelo de Machine Learning, lo que a final de cuentas tienen que subir a producción, que tienen que poner a producción, no solo es el modelo de Machine Learning que ustedes entrenen, sino todas las transformaciones previas que le hicieron a los datos. Normalizaciones, tokenizaciones, si están trabajando con texto. En este caso estaban dividiendo la fecha entre hora y día, me parece. Entonces, todo eso tiene que formar parte de su sistema de Machine Learning, no solamente el modelo que ustedes entrenan. Es bastante importante mantener todas estas cosas alineadas. Y bueno, es de lo que está hablando prácticamente.
So you have to basically remember in every production system that you need to add 78 to latitude and divide by 8. I mean, who's going to remember that? How are you going to keep that up to date, etc.? So much simpler if you have these kind of simple scaling, formatting, clipping, all of these kinds of things. Throw them into a Lambda layer in Keras, make it part of your model. So this way, now your model, right? You have three things. You have inputs, which is the raw data, with the features that you've created, and you basically go from inputs to features using these transformation layers. And this is the way, when you keep them separate, it basically becomes productionization become easier. So the basic transform pattern is that the model graph includes the transformations that you do to go from the inputs to the actual data that you use in your ML model to train the ML model. The model still uses three features. But the key thing is that the transforms are layers in your model graph. And because they're layers in your model graph, it becomes so much easier to productionize. Now, is this the only way to do it? Absolutely not. There are lots of trade-offs here. And in the book, we talk about two other patterns. We talk about TensorFlow transform, which is a way of basically making things more efficient so that you're not doing it in Lambda layers. We talk about feature store, which is another way of making things more efficient so that you pre-compute these things beforehand. But transform is the simplest pattern that allows you to limit training serving skew. So it's worth knowing and it's worth implementing in a lot of your projects. The next pattern that I want to talk about today is a stateless serving function pattern. Okay? So why does this come about, right? Imagine that you've trained an ML model, right? You've trained a model that you basically pass in some text and it basically gives you a classification, some kind of logics. Maybe it's sentiment, maybe it's topic modeling, it's something. Now, in order to basically call this method in, like when you want to predict with it, you would just call model.predict and pass in a tensor corresponding to the sentences for which you want the sentiment or topics or whatever. Now, this is problematic because what? You need the model in your prediction system. So you have to load and retain this entire model into memory. And that's pretty wasteful because a model contains things like the epochs, contains dropout nodes. It has a whole bunch of state that you don't really need for predictions. Secondly, the model typically is not thread safe. So you're going to have latency limits. You cannot basically just call this all the time. You cannot thread it, right? You cannot do things in parallel. And also, just as with the transform that I just talked about, you will often need to support a different input than what was used in training. So when you're doing training, maybe you just train it on a single sentence at a time, but in your prediction system, you want to take a paragraph and you want to split it into sentences and then call the predict on all of those sentences. And that's what your API needs to be. Your API that you're using for prediction may not be the API that you use for training. And so, relying on model.predict is problematic. So what do we do? Well, one way to do this is to export the model. So you basically take your model and you basically say, okay, I've written this model out, and now I can just load the model. And when I load the model, I just retain what are called signatures in the model, right? And the signature basically is the thing that you call, and the signature matches the input layer of the Keras model. So now you basically get a function, And you can basically call that function, passing in the whatever data is needed by that function. And now this function is something that you implement to invoke the model. So this is great, right? So prediction signature, you have this idea of a function that is separate from, right, the input layer, but the prediction signature matches the input layer. Okay, but if the prediction signature and the input layer are the same, then you still have abstraction problems because, hey, remember, you're still loading the model. So that all of those problems exist still now, and it only works in Python, right? So you still have your abstraction problems. So what's the solution here? The solution here is to use a stateless serving function. The idea is that you take this model and its serving function, you wrap it up in a web serving infrastructure. A web serving
Es un poco extraño porque muchos de estos patterns son cosas que usualmente ya como desarrolladores de software conocemos. Básicamente lo que están hablando aquí es de poner cosas detrás de un API, ya sea un HTTP, REST, ya sea un JSON, que comuniquemos con JSON con esta API, o que utilicemos gRPC. Pero bueno, de nuevo, estos patterns no es como redescubrir la rueda, ¿no? Sino ponerle un nombre a algo que ya conocemos y que ya usamos normalmente.
That's capable of being accelerated in another framework that gives you managed services that automatically scale up and down, right? Depending on the amount of traffic, they do load balancing and all of those things that you would expect of a web microservice. So now, as far as a client is concerned, they just need to give you a JSON and you will give back them a JSON. It's now a REST API. And they can forget that they're calling a machine learning model with tensors and all of that stuff. They're just sending you a JSON request and getting back a JSON response. So why does this work? It works because this ability to scale web endpoints, and remember, this is what TensorFlow serving does. It gives you a web endpoint. Auto scaling a web endpoint is a well understood engineering problem, right? All of your cloud providers know how to do that. No big deal. It's fully managed. The cloud platforms abstract away the managing and installation of like TensorFlow and all of that stuff. They basically give you, if you use AI platform, you use SageMaker, you use Azure, right? You basically get this, all the installation stuff out of the way. You don't have to worry about it. The prediction system is already done. Now, because you're sending back and forth REST APIs, it's language neutral, right? You can do this from Python, you can do this from Java. You can even do this from PHP if you want, right? Everybody knows how to speak HTTP. And because these are web applications, you have a really powerful monitoring system, right? So all of your MLOps become a lot easier because MLOps is now just DevOps. You're monitoring and throttling your tools, and your SREs know how to do it, your IT admins know how to do it, your DevOps people know how to do it. So this is why you basically have these 3 layers of the onion, and it's super useful to be able to do that. Okay. Now, how does it matter to us as data engineers? Well, remember I started out by saying you need abstraction, and the serving API, the default one, basically gives you the same inputs as the Keras model, but you don't have to live with that. You can change the input signature. So what you can do, for example, and I'm showing you a very simple example. Let's say that every time somebody gives you a file name, they also give you a sequence number. And when you return the result for that file, right, you also need to provide the sequence number that they gave you with the file. You need a pass-through. Well, the sequence number was not an input to the Keras model, so it will not normally be present, but it's very easy to add it. This is what you do. You write a function, you add a TensorFlow, you say that this is a TensorFlow function, you get the original serving default, you make the original call, you get your result, but this result is a Python dictionary. So go ahead and add in, right? Here are the file names you gave me, here's a sequence number you gave me, and there is your result. So now you basically get back a JSON that has what the model would have normally provided as output, but also some input pass-throughs. So now when you export the model, when you save the model, you can save it with 2 signatures. one with the original serving default, and another one with an input pass-through. And then when somebody calls your model, they can choose whether they just want the bare bones functionality or they want this additional functionality. And obviously, as you can see, now it's just basically based on the JSON request, and you can do anything that you want in here. You can call your backend database, you can enrich the data, you can do all.
Está loquísima esa funcionalidad de TensorFlow. No la conocía. Como que lo hicieron más cercano un poco más amigable a ingenieros de software.
You can add to your ML model. So that's why you have this concept of a serving function and this idea of having it be stateless so that it auto-scales. The third pattern that I want to talk about is that of continuous model evaluation. If as a data engineer, one of the things that we often want to put in place is a way to detect things like data drift and concept drift, right? So continuous evaluation is well after the normal parts of your ML lifecycle, where you're basically exploring data, building an ML model, and you're deploying the ML model. At some point, you will want to start monitoring a model that you put into production to see if it is still performing as you would like it to perform. Okay, why? Because models become stale over time, right? For example, right, when the credit card started to have chip-in-pin technology, right, it became really hard to fake a credit card in the physical world. So many more fraudulent transactions start to move online, which means that any fraud detection model that you trained.
Dale, Humberto, cuídate, mano. Espero estés bien. Sí. Les paso el enlace de las conferencias también por ahí.
This probability distribution is going to keep shifting, and you have to keep retraining the model every time the performance drops. Okay. Another reason for concept drift is that, like, if you have a word model, the meanings of words changes over time. Well, when people talked about trolls, right, they were talking about dolls before, but now they're talking about annoying people online. When people talked about cells, they were talking about prison, but now they're talking about mobile phones. We talked about cloud, they were talking about meteorology, and now we're talking about data centers, right? So these words acquire new meanings. So you have to retrain models that are reliant on language. Okay, so the other thing that can happen is that the probability distribution of data itself can change over time, and that basically causes models to become stale. So how do you do this? You need a way to compare a model prediction with ground truth after the model has been deployed. So the way we do this, right, is how do we do this? Well, because we have a model already deployed, it is receiving new data all the time. That's a key thing to realize. It's receiving new data all the time, and it's making predictions on that data. And in many cases, we can go find the ground truth. The ground truth might be delayed. So imagine that you are basically training an ML model to predict whether somebody's going to abandon a shopping cart. Well, 24 hours from now, you know if the shopping cart was abandoned or not. It's just delayed, right? Other ways is you might have to basically save your part of your input data, send it to human labelers, and have them label that input data, and that way you get your ground truth. So the idea is that you save the predictions, not all your predictions, because that will slow things down, but a fraction of your predictions, usually like 0.5% or 0.1%, 1 in 1,000 predictions, so that you can basically compare it with the ground truth. And so what you will then get is a table that looks like this. Here's the model, here's the version number. At this time, you basically go ahead and you had your, this is the text that you passed as input. This was the output that it provided, the probability, the output thing that, the actual, then you have to fill in the actual ground truth when you do have it, right? And you might have it through human labeling. You might have it because later on, you basically have a better way of finding what that actual answer is. And now you go through your sampled predictions, and now you have a new data set. And what you do is that you compare this data set over time. You say, okay, let me go ahead and find the evaluations for more than a month ago, more than a week ago, etc. And you start comparing it. And what you will start to see is that as time goes on, performance will start to dip. And you might set a threshold and you say, every time the performance goes below a threshold, go ahead and retrain. We can, once we do this, it also allows us to compare performance across model versions, right? We have a new model, we can basically take the same input and split it, and we have this new model running in the shadows. So the first V1 is what is being used in production. We have a shadow model, which is V2, that is all of the traffic is being sent to it, and we're saving the results of both V1 and V2, a sample of them, into our evaluation database. And then once we get the ground truth, we compare against that ground truth, and then we basically see when do we switch over from V1 to V2, right? So how do you get that? Oftentimes it's just a matter of time, right? A month later, you know which transactions are fraudulent, right? When somebody basically comes and complains about it to you. Now, a few days later, you know which shopping carts were abandoned, okay? Other times you may have to actually do human labeling, okay? Or you might, if it's a medical situation, you might know if this patient had to be readmitted, etc. So you basically use that, you look at how the performance changes over time, you retrain, and what you basically get is a performance curve that looks sort of like this, okay? And the idea is that if you can do this much more often, now you basically get the ability to maintain a much higher performance, right? So the idea is you start setting this up so that as you get new data, you take that new data with the ground truth, you throw it into your training data set, you retrain automatically, and you set this up as an automated process, okay? So if you don't do this, what else are you doing? Well, what you might be doing is that you might be doing things in an offline environment. So you train a model on some data, you basically put it into production. 6 months later, you take that old model, you now have new data that you've collected over the last 6 months, you evaluate on that data, and if it's not good enough, you start doing the retraining. What we are doing with continuous evaluation is that by saving this sample of predictions and over time, we basically get the ability to continuously improve it. So with that, like I'll come to the end of my talk. We talked about 3 patterns here. Again, 3 of the 30 ones that we cover in the book. So there's the link.
El libro es bastante bueno, se los recomiendo.
Read the book online. That's the code for that trial, MLDP, Machine Learning Design Patterns 20, because the book came out in 2020. My co-authors, Sarah Robinson and Michael Munn, you see them on the slide here. Follow me or Sarah on Twitter. Michael has a life, so he's not on social media, but both Sarah and I are. So you can follow us on Twitter, you can read our blogs, and again, all of the code to illustrate how this all works is on GitHub. Thank you.
Michael has a life, so he's not on Twitter or social media. I love that, man. I love your presentation. That was great seeing you again present. You got a minute to answer some questions?
Absolutely, absolutely.
Awesome, awesome. So, of course, I asked you all the questions I could.
Vuelvo con las preguntas, ahorita regreso.
And I highly encourage everyone to get this book. Definitely, I got it. We've been talking about it in Slack. It is very cool. The question coming up, is there going to be a new edition of your book?
Is there going to be a new edition of the book? I mean, there over time, I'm pretty sure that we will identify newer design patterns, and some of these design patterns will become obsolete. And so I imagine that we might want to do a new edition of the book. We're not ready to think about it yet, right? Writing a book is a largely thankless job. It takes a lot of time away from doing the things that Google pays me to do. So yes, maybe. At this point, I've only identified one idea that I might want to include, which is about how to represent geospatial data. So maybe I might just do blogs instead. And once we have enough material in blogs and articles, we might consider basically doing a book. But I mean, and the other thing about doing a book is that you always have to drop things. I think 30 is about the limit. So we'll have to go back and take a hard-nosed look at the ones that stop being relevant over time. At this point, the book is only about 6 months old. It's all pretty relevant, so I don't see a need to change it immediately.
Yeah, and they're already asking for the new updated version. Oh man, it's ruthless out there, Lack. And I think it's
tough room, man. Tough room.
Yeah, exactly. It's also very funny that you say that it takes you away from doing the stuff that Google pays you to do. So I can understand. Now, keeping with the book theme, what is that bird on the front cover?
This bird is called a sunbittern. It's kind of like a wild turkey from South America. And those, it has this, it's like a peacock. When it spreads its feathers, you basically get these huge eyes. So it makes the bird look like it is much larger than it is. So when it sees this predator, it basically spreads its wings, and then you get those red spots. They look like huge eyes. You should go look at a photograph online, right? It's amazing. And it basically looks like it's a scary thing. And no, I did not get to choose the bird. I just love the bird. I had not heard about the bird before. O'Reilly assigned the bird to our cover, right? We authors don't get to choose the animals on our covers.
All right, so people are getting pissed at me that I'm not asking any machine learning related questions here. Here we go. What are the cons of putting feature engineering as a layer instead of doing it outside?
Yeah, absolutely. And this is something that we get into quite a bit in the book, but let me kind of summarize. Number one, training a model is an iterative process, which means that if you train the model for 100 epochs, there's 100 epochs times that you're basically doing this pre-processing over and over again. So the more expensive your pre-processing is, the more computationally expensive your training process becomes. And the way to address that, that's what TF transform does. TensorFlow transform basically figures out a way to do this only once rather than all the time, but still have the stuff be part of the model graph. The con is now your architecture is a lot more complex. You now have to have TensorFlow transform. You need to have a Apache Beam. You need to have these artifacts in your model pipeline, right? Your setup becomes more complex. The nice thing with the transform pattern is that it's simple. The trade-off is you're going to be doing these computations many, many times. Your computations are cheap. Your time is more valuable than the computer time. And I strongly recommend that you let the computer work a little bit harder so that you don't have to be up at night answering pagers.
Incredible. I love the way that you put things, man. All right, you got to come back on the MLOps community meetup because having you on here just inspired me. There's so many questions. Are a bunch left in Slack. We have probably time for one or two more maybe, depending on how.
Pero bueno, ¿qué vamos a cenar? Es la pregunta verdadera. No creo que me dé tiempo para algo, así que vamos a ir pidiendo comida, ¿no?
Again, there's an entire pattern called batch serving that we get into many of the trade-offs here. So I'll kind of summarize a little bit here. In some cases, you want it to be a separate service. In some cases, it is a good idea to load it internally, but when you load it internally, you have to be very careful to basically take into account things like state management and things like distribution of model state. So it is not, so there are times in which you will want to keep it as an API and times in which you want to keep it as a shared model handle and times when you want to load it as not a shared model handle. So all of these possibilities there are instances in which they're the right approach, right? So it's not like you do one always, but there are certain classes of problems for which you want an API, certain classes of problems for which you want to load the model into the pipeline, certain class of models where you want a shared handle in an Apache Beam pipeline, and we talk about those.
Nice. All right, last one, and then we really got to go. So, could you? No, wait. Sorry. Is there any study that shows that overfitting decreases or increases as we do continuous model evaluation?
Is there a study that talks about overfitting and continuous?
La pregunta está muy extraña.
Whether you do continuous model evaluation or not, right? You do need to train on a representative sample of data. And all we're saying with continuous evaluation is that the world is dynamic and the representative sample of data will change over time. So I don't know, you are not training exclusively on new data. If that's what you got out of it, I'm sorry, that's not what I'm talking about. You're continuing to train on a representative sample of data, and you're hoping that if like over time, if the probability distribution of your features change, that you're dropping the older bits and you're replacing the older data with the newer data. So think of it as training on a moving window of data, but that moving window of data is still a representative sample. It's very important that it is representative.
Excellent. For any more questions, go read the book.
Okay, vamos a pedir algo de bueno, ahí está mi dirección.
Supporting a good cause.
Oh, you're making me feel bad with my affiliate link. All my affiliate link royalties go into my pocket.
No, that's fine. That's fine.
Que vamos a pedir una pizza, tal vez. No sé. Este Deliveroo es como el Uber Eats. Digo, también hay Uber Eats por acá, pero no me agrada tanto. Podemos pedir una pizza de Pizza Room. Y tal vez algo como Margarita, Summer, Springtime. No olvídenlo, no de Pizza Room. Pedir de Pizza Union. No sé, Doc, no pasa nada de todos modos. Abre spicy. Vamos a pedir de pepperoni, supongo. Y quiero nada extra. Y bueno, y ahora sí. Vamos al checkout.
Before that, he worked at Adobe as a product manager. Welcome to the both of you, and I think we're ready to get it rolling.
Hello, welcome everyone. Thank you for joining us today. My name is Simarpal. I'm a product manager at Intuit. I'm joined with my colleague Ian, who will introduce himself today. But today we are planning to share with you an overview of our machine learning platform and how it powers the real-time personalization of Intuit QuickBooks using Clickstream data. Ian.
Hi, my name is Ian. I am excited to be here to share with you the Intuit ML platform and personalization. Thank you.
Okay. Thank you, Ian. So with that, as an agenda for today, I would briefly mention about Intuit and where machine learning is used in its product. Then at a high level, I will talk about the components of the platform. And after that, we'll go into details about the featureization and model inference pipeline. And we'll end up with a demo clip to show how the pipeline actually powers the in-product experience today. So at Intuit, we serve consumers through products such as TurboTax and Mint, and also small businesses and self-employed through our products such as QuickBooks. And in terms of where ML is used in product, a few examples mentioned are the search relevance for TurboTax, QuickBooks, and cash flow forecasting for QuickBooks, uh, and then providing proactive help within product and doing automatic transaction categorization, for example, in Mint. Now, if you read the mission statement of Intuit, then it says that the mission is to power prosperity around the world with AI-driven expert platform. Keeping that in mind, ML platform vision is to democratize AI ML development for anyone in Intuit by simplifying all the parts of the MDLC that you see over here through automation and self-serve user experience. Now, if we look at a high level, there are different types of technology used in each phase of model development within the platform today at Intuit. So on the feature engineering side, we provide Apache Beam, Spark, and Flink as a compute a framework running on Kubernetes infrastructure. And for feature storage, we use DynamoDB and S3. For model training and inference, we have AWS SageMaker. And for model monitoring and anomaly detection, we have in-house capabilities built. For the purpose of today's talk, we wanted use case.
Tengo una ligera sospecha de que los que se ven así como muy raros, muy mermeladosos, es porque son grabados.
And a series of events, which we call Clickstream, is sent to the Kafka-based event bus, now which are then persisted also into the S3 data lake. Then these events are used to do real-time personalization, real-time featureization. For prediction, features are fetched from the feature store and combined with the request payload to deliver the customer experience within the product. And we also have the, as I said, model monitoring and the feedback loop to further improve on the product experience and model performance over time. So now next I will gonna go deeper into how the featureization pipeline is built. So as a platform, so for the purpose of this talk, as we said, we will be focusing on the real-time personalization pipeline. So as a platform, we provide choice to the data scientist and machine learning engineers to use different combination of distributed processing frameworks like Spark, Flink, and programming languages such as Python, Java, and Scala. So in this case, the Clickstream pipeline to do featureization is built using PySpark framework running on Kubernetes-based infrastructure. The key components of the pipeline, starting from the left-hand side of what you see in the diagram over here. So we have a Kafka-based, real-time messaging system where all the Clickstream events, what the user is interacting with the product, they come into it. And there are several thousand TPS of Clickstream events that come in, and they are processed by highly scalable and distributed compute running on Kubernetes infrastructure. So in this case, the feature processor is written using PySpark. And for that, we also provide programming interface for developers to easily operate on data frame objects to apply their transformation and produce features. Once the features are produced, they are sent to another Kafka topic from where, what we call as the ingestion topic. And this acts as a shared message queue for both the stream writer that writes to what we call as the online store and a batch writer that writes to the offline store. And the reason for this is to ensure there is consistency in feature values that are used at the time of inference and training to avoid training serving skew. The data scientists use the feature values stored in the online store, which is backed by S3 and Hive table to do their model training. And at the time of inference, the feature values are fetched from the online store for in the real-time fashion to provide low latency response to the application. The low latency store that is built using DynamoDB, where is built using that, and where we had taken several design consideration to support different types of feature values and associated queries. For example, few feature values could be like a profile information about a user, but then there are also features, which are tracked on certain dimensions, say time, for which some aggregations are applied, and then those values are actually fed into the model. Some of the other design consideration we have to do is around the compliance needs, such as GDPR and CCPA, where these feature values could be deleted if a specific user makes a request to be forgotten and removed from our databases. The last piece of the component that you see over here is the data serving layer. So this is a GraphQL-based web service. Using this, the data scientists and engineers can fetch features as needed, and they can combine features across different feature set. In case of training, what this does is basically generate transpiled query that could be run on distributed compute to create training set that can then be fed into the model training process. And in case of real-time inference, it can directly return feature values from the store. In addition to what you see over here, we also provide users the backfill capability in order to backfill historical value of the feature. Backfill is another key capability and not an easy one, as we have to do some orchestration between the backfill job and automatically transition to process stream events which are coming live. To make it easier for our data scientists and machine learning engineers, we have provided this capability as part of the platform, out of the box. And if you look at this whole pipeline, the end-to-end latency is actually in a very low single-digit seconds, and which worked for this specific use case around real-time personalization that we spoke about. So next, I wanted to talk to you about the development experience, what the development experience is like for our data scientists and engineer. Uh, to build the feature engineering pieces, we provide self-serve experience on a developer portal where within few clicks the users are able to provision GitHub repository to write their processor code. Inside this repository, there are actually boilerplate code with simple examples for user to quickly get started and customize the code as per their needs. We also provide feature store SDK, using which the users can easily serialize the data and store those values in the feature store. In addition, we provide Jenkins build job to build the code and also a namespace on Kubernetes cluster where pipelines are run. Now, in order to make sure that the features get properly stored with proper metadata, because
feature store
discovery, we have a feature set registration process also, where we actually capture the descriptive information about the feature and also other information such as compliance related to CCPA and GDPR. And as I showed in the previous diagram, there is an ingestion topic that could be used in a self-serve manner to basically process the features into the online and offline store. And one last step is to create the schema for the GraphQL query for downstream consumption for model training and inference. And this is also provided as part of the onboarding process onto the feature management and the feature store. Another important aspect of these pipeline is to provide visibility to our user into the operational metrics and cost considerations. So we provide these out of the box Wavefront dashboard to track metrics around Kafka to see how many messages are getting processed and investigate if there are any consumer lags or not. So all these abilities are provided in a much more seamless manner. As soon as they onboard their use cases, they are able to view through these Wavefront dashboard. And the cost dashboard basically helps the users to look at the ROI of their investment as to how much are they spending in running these pipelines, to what value are these pipelines generating through customers in terms of providing benefit. And the last, importantly, like we provide the complete lineage tracking also for our users. Again, this happens through the metadata registry MDR component that I talked about earlier to see how the pipelines are built, what are the components across the board, connecting through different components as the pipeline goes from processing the data to storing the data and then making it available for downstream model consumption. Next, I would hand it over to Ian, who will walk you through the inference pipeline building experience and how does the model consume these features for inference.
All right, thank you for that, Simar. So today I'll talk about the inference pipeline that relies on the feature store in order to get the features and personalize the models. So what is model inference? As part of model inference, it covers deploying and hosting of the model, getting the features from the feature store, giving them to the model and getting a prediction. And last but not least, monitoring the model to make sure that it's producing the right results from my model efficacy, and also operational monitoring to make sure that the model is up, it's giving the response time in the expected SLAs. That way the customer is getting really a personalized experience.
Dale, nos vemos, Totón. Cuídate. Gracias por seguir la conferencia por acá.
Experiencing. So as part of the model deployment, what happens is there's an interface. It's self-serve for the users, in this case, the data scientists and machine learning engineers. Everything is in a central dashboard that can be accessed through our developer portal. There is container orchestration, which the platform handles. Everything is running in containers. We make sure that it's meeting SLAs, it meets the security standards. And of course, you have the dashboards for monitoring, and you also have a status to know, is the model up or down? And I'll go into the dashboards at the end of this presentation when it comes to monitoring. So that is deploying and hosting. The next part is around feature fetching and orchestration. So for the feature fetching and orchestration, the way we've done this is that the data scientist is the author of a contract. We call this an escrow contract. The escrow contract specifies that these are the features I want to get. This is how I want to manipulate these features. And on top of that, it also specifies which model these features are supposed to go to. The contract is authored by the data scientist. It's abstracted away from where the data lives. So they just specify, this is the data I need. We on the ML platform side will go ahead and connect to the feature store, get the data they need, send it to the model, and then send the predictions back. So we've abstracted this so that there is a simple interface between the data scientists and the client teams, and that simple interface is just a REST endpoint that the client teams call. Next, I'll go a little bit into the details of the feature fetching because this has a lot of patterns. And given that we are talking about real-time personalization, I'll talk a bit about what are the different patterns. So first of all, this is for the real-time inference, even though we can handle offline, but because of this talk, we are talking about the real-time aspects of it. It's based on a DAG, and I'll show you how that is materialized via the different nodes. And I'll go into details of the different feature fetching mechanisms and orchestration. We have model/data dependencies, parallel execution, data transformation, or what we call last mile transformation, and also asynchronous execution. All these are the different ways we can get features from the feature store and feed them to the model. So for the feature orchestration, I'll start with the model and data dependency. The way you read this is you read it from the bottom going up. The one at the top, model 2, that is what will finally be executed. So for the data, assume that all this data is coming from the feature store. So you can see that you can have the data come from the feature store, and then the different nodes can manipulate the data in order to get it into a certain format and then move this data to the upper nodes. In this case, you can see that model 1 gets the data from the feature store, which is data 4. It gets the output of that, and then that will feed into another model. So you can see model 2 depends on model 1. At the same time, it also gets the data from the feature store via feature 4, and all of these will feed into model 2. That is for model and data dependencies. The second one is parallel execution, and what this means is that if you see features 1 and features 4, these will be retrieved from the feature store at the same time, and then they'll feed back into the different aspects. In this case, feature 1 will be used by another processor.
Como que esta plática no está tan buena tampoco.
2 will also use the same feature. But when we get the features from the feature store, we'll get features 1 and 4 at the same time. And we can get up to n features from the feature store at the same time. We have some models that actually rely on 300 features. And then the other part that I want to talk about is you can also get features after you've done the parallel fetch. You can also do some light aggregation, as Sima talked about, and then the aggregation of that data will be sent to the other upper nodes, in this case, model 2. Now, how does this affect the personalization? For example, if we take features 1, 2, and 3, it could be that the features that go into model 2, it's an average or a summation of these, and depending on the average, the experience will be different for the user. So the red arrow indicates a point within the node that is doing some feature processing. Now, all of this that I'm talking about happens on the model serving layer, and we on the ML platform, we handle that. Last but not least, I want to talk about the asynchronous nature. What this means is that you can have two models, even though there's an intermodal dependency, they can send their own predictions independently of another. What this means is that model 1, after it has done its processing, it can send its output to the calling service. At the same time, model 2, even though it's depending on model 1, it will independently send the output of the predictions to the upstream services. They do not have to wait for each other in order to materialize the final predictions to the upper layer. So all of these different patterns are handled by the ML platform, with the user just specifying that I want these features to be gotten from the feature store. Now, last but not least, I'll talk about the monitoring. In this case, you have the monitoring of the model predictions on the operational side. What this means is that, one, the user can specify, I need to get these requests per second, and I need to monitor them on a percentile basis, on a mean basis, so that if there's anything that goes wrong, they can take some action. And this is provided by the platform right out of the box. The user does not need to do anything. And one of the things that also we take care of is to make sure that we are monitoring the feature orchestration processing time, because of the online nature of these models. We need to make sure that the predictions or the feature fetch are produced in a timely manner. So we always monitor that. And if the orchestration is taking long, we can have an alerting and have users take a look. The other part, when it comes to the model monitoring, is monitoring the predictions themselves. This is the actual predictions that are coming out of the model. In this case, you're monitoring them on a statistical basis. The table on the left shows you some.
Las conferencias son un poco extrañas porque, bueno, por ejemplo, esta plática siento que no vale tanto la pena. Solamente es como que nos cuentan un poco de experiencias de lo que ellos han hecho, sin explicarnos necesariamente cómo es que lo hicieron. Y bueno, al menos, si bien tiene un valor como tal, no sé qué tanto lo sea. Y bueno, y es que particularmente estas explicaciones tienden a ser muy vagas y bueno, en este caso es muy, muy larga, en mi opinión. Pero bueno, la buena noticia es que ya viene la pizza y después durante la pizza va a haber otra, como que un panel, y de ahí termina la conferencia, al menos la transmisión. La conferencia va a seguir si ustedes quieren seguirla viendo, pero de todos modos falta una plática, un panel.
Whereby you have your Clickstream events, you're doing the online featureization on the streaming data, you're storing the features in an online store. On the inference side, the model is deployed, it's up and running. The ML platform is getting the features from the feature store. It's handling the orchestration of various features, combining them, and doing monitoring. All this ends up providing a personalized experience for our users based on the data that is unique to them, while ensuring that we are powering prosperity for our customers. And now I'll go ahead and show you how this looks like from a user perspective, and you'll see how this is actually realized for our users. So as this is loading up, I'll show you what this looks like. So in this case, give me a second.
Es grabado, se ve como si le hubieran embarrado mermelada a este video. No me gusta, para nada. Pero bueno, igual hay muy pocos viewers ahorita, así que... Para la próxima, porque seguramente tendré que ir a más conferencias, atender más conferencias. Si son gratuitas, las voy a volver a transmitir, pero obviamente voy a avisar con más tiempo para que si quieren caerle a verlas, más que bienvenidos, ya saben. Comentarios en vivo.
For an assistant, and you see that the data that is presented to them will be dependent on the data or on the previous actions that they have taken. So now you see the user, they are logging a transaction. They're adding the transaction within QuickBooks. They try to connect to their bank, but then they decide not to. They go to the Mail tab, and they're going to record a trip. So as they're recording, they're putting in the starting address. And now they don't know why they can't save, and they realize they have to put in the trip purpose.
No, esta es... que ya me quejé mucho de la presentación, pero bueno. No, la pizza está aquí, muy cerca, muy cerca.
But here, once they've clicked the Help tab, I'll take a pause here and I'll show you. You'll see that based on the transactions.
No se ve nada, no se ve nada. Súbele la calidad del video. ¿Hay alguien que se esté quejando de la calidad o soy solo yo? Nadie más se está quejando, soy solo yo. Estoy volviendo loco. Creo que algo malo. Creo que está pasando ahorita también. Poco feedback y significa que la cosa va mal. Como es transmisión.
And of course, you can see that these other subsequent help tabs, they're also dependent on the previous Clickstream data or actions that the user has taken. And that marks the end of the presentation. Thank you very much. Sima and I will be available via Slack to answer any questions that you might have, and we look forward to the discussion that this is going to elicit.
Yes, thank you very much, guys. It was great sharing our platform and information regarding our personalization pipeline. Feel free to reach out, as Ian said, on Slack.
Excellent. Thank you, fellas. That's very cool to see. I appreciate the transparency and how you show us all of the details on all of that. So, as always, ask them questions in Slack. I'm just here to add a few updates before we get cracking. We're going to be going at 10 past the hour. A few updates. If you haven't heard already, there is a meme competition going on. Give us your best meme, and we want to see that in the funny channel or on Twitter, #applied_meme, or show us a GIF and explain the MLOps tooling ecosystem in a GIF. I want to see some of that. It looks like it's shaping up to be pretty funny. So we've got those two things happening. Also, it is worth mentioning that Tekton is hiring. So in case anyone wants to work for them, reach out in Slack. They are hiring fast. Lots of good stuff, lots of good people working there. So last but not least, if you haven't filled out the poll, go ahead and fill that out. We have that in Slack too. The poll is going to be...
Así llega la pizza, así que va a ser hora de alejarme un poco de la consola. Pero es muy probable que termine la transmisión para poder comer en paz y que este video no sea tan largo y no arruine un poco aún más mi reputación de streams. Pero bueno, ya veremos, ya veremos.
It's actually a panel discussion next up. And after that, we'll start with the lightning talks. I'm going to be giving a lightning talk, if you can believe it or not. I'll be with my man, Ivan, aka Leonardo, and we're going to be talking about what the MLOps community is. So jump into that and you can hear all about what we're doing in the MLOps community and specifically around some of the initiatives and the engineering labs that we've got going on. We just kicked them off this week. And speaking of people that are helping out with the engineering labs, we have Simmer Paul, who is giving a talk to people in the engineering labs, but we're going to talk all about that in my lightning talk. I'm getting slacked. Why am I talking about this? Forgive me, people. And also, okay, this is the last thing, and then I'll let the hold slide. Playing that guitar over there, right there, in the next break. So after this panel discussion, I'm going to be asking people in Slack to put some random things that we can sing about in Slack. All right. So in the Applied Conference channel, we can start a thread. I'll start it off right now and just throw some random stuff. Maybe it's about machine learning. Maybe it's not about it. It's about mustaches or whatever. And I'll make a song about it. I cannot promise the quality of that song, but I can promise that I will play that guitar and we will be singing Kumbaya in the next break after the panel.
Pues Ale, se me hace que me despido. Digo, la conferencia va a seguir, obviamente. Yo me voy a ir a cenar. Y nos vemos en la siguiente. Gracias a todos los que anduvieron por acá. Disfrutaron de la conferencia conmigo. Ya saben, para la siguiente les invito con más anticipación para que si quieren puedan preparar. Tengan ahí algún snack, alguna cerveza. Pero, pues nada. Cuídense mucho. Ahí nos vemos. Saludos. Muchas gracias a los que anduvieron por acá. Muchas gracias a los que están viendo esto ya después. Bien. Pues vale. Cuídense mucho. Tomen agua. Y nos vemos al rato.
The Tekton folks had a lot of faith in me. They didn't let me organize and lead the panel. They said, we're going to get somebody that actually knows how to do this stuff. So they got the founder and editor-in-chief of the New Stack, Alex Williams, to come and put this panel on. If it was anybody else, I may have been a little bit angry, but considering the clout that Alex Williams has, just got to let him do it. And there he is. What's happening, Alex? It's good to have you here. And I think you're
thanks,
unmuted.
man. I'm
There he
looking
is.
forward to hearing all these songs. I want to hear one about, I mean, Ops is like kind of on my mind, you know. That maybe that's a song. Ops is kind of on my mind.